Welcome, everyone. We are here for the completely free Azure Solutions Architect Expert Bootcamp. My name is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers, and I've been an architect now for well over 25 years. I love this role, the cloud architect, the network architect, the enterprise architect, the AI architect. I've lived these roles forever, and I've loved them, and they're fantastic. So we're going to have 2 weeks of fun. Let me know where you're at in the chat box. I see lots of people. I know lots of people from all over the world. I'll give you some information about what we're going to do, give you some housekeeping, let you know the flow so you know what we're going to be doing. So this training itself is designed to prepare you for the AZ 305, the Azure Solutions Architect Expert, the Microsoft Azure certification. And this is going to be a free, full Azure course. So the way we're going to run this course is going to be as follows, and it's based upon my 25 years as an architect, interviewing approximately 6,000 technology professionals over the year, and training people that now work at Apple, at Amazon, at Cisco, and Google, and IBM, and Accenture, Deloitte, KPMG, Capgemini, PricewaterhouseCoopers, Callian, Barclays Bank, JP Morgan Chase Bank, and so many other organizations. So we're going to have lots of fun. What we're going to do here is going to be in the following. During this first week, what we're going to do is we're going to really peel back the onion on what is cloud computing. I'm going to assume you start at zero. And the reason I'm going to assume you start at zero is as follows. After interviewing 1,000 AWS and Azure certified people that have certifications like the AWS Solutions Architect Expert, AWS Solutions Architect Professional and the Azure Solutions Architect Expert, very few were actually able to tell me anything about architecture. Very few were even able to define cloud computing. So what we're going to do in this first week here is we're going to break down all these cloud concepts. We're going to make sure you understand what's going on under the hood. Because if you don't understand how the technology works and how it fits together, you'll not be able to do any kind of architecture regardless of your certification. So first week, we're going to talk about the tech. We're going to explain how the tech works. We're getting involved in a lot of fun whiteboarding. Now, in approximately the second week, what we're going to do is we're going to actually do the more official Azure Solutions Architect Expert training, which means we're going to cover a lot of the things we covered in the first week, which means it's going to be your refresher and your exam preparation. But more importantly, in that second week, we'll cover the things the way Microsoft wants you to know it to pass the exam, because I want to make sure you understand the tech. What is the tech? How does the tech work? Why you need it? Because that's what's going to ask you in an interview. They're not going to ask you to configure something. Now, I did have my team create a tremendous number of fun hands-on labs for you, and I want you to download it. My team will pop the link to these free downloads in the chat box. I want to spend all of these next 2 weeks, every last minute that we have, making sure you understand cloud computing. You understand what kind of technology exists in the cloud, on the cloud, off the cloud, hybrid, multi-cloud, so that you're not just going to get certified. You know something, and you know how to problem solve, and you have the skills to help you more in your career. So sign up. That's going to be completely free. My team will pop it in the chat box and the description of this video. I'm also going to let you know that once per week, we have a completely free webinar on how to become a cloud architect, or how to become an enterprise architect, or how to become an AI architect, or other forms of architects like security architects, because I want you to know what it takes to get hired. And these are free webinars. We'll talk about these roles and what we do in these roles. And at that point, we'll be on Zoom. You can ask as many questions as you want, because I want you to have great careers. So please sign up for these free. We run them once a week. We're going to begin in a few minutes with our Microsoft Azure training to prepare you for the Azure Architect Expert exam. We're going to have lots and lots of fun. I'm also going to make sure that you understand the concepts. We're going to teach for approximately 20 minutes or so, as best as I can actually remember time-wise while I'm teaching, and then we'll take breaks for about 10 minutes, because I need you to actually be able to understand it. If you miss a day, it's okay. We're going to leave the recordings up on YouTube so you can have it for as many times as you want. Please share these recordings with a friend. Please invite somebody. I'll give you a minute to do so, because it costs about what a car costs to put one of these 2-week sessions together with the amount of people and processes and things that we actually use. So I want to make sure as many people get to take advantage of this free training. Now, I'm looking at where some of you are from before we begin, and it's really kind of interesting to see. I see some of you folks are in the UK. I love that. Some folks in Nigeria. I love that. I knew we had some people. I know we've got lots of people in Cameroon. I see Kentucky. I see India. I see Canada. I see Lebanon. I haven't been to Beirut in a while, but it was beautiful the last time I was there. I see Colombia. I haven't been that way in a while. And I've spent lots of time, obviously, in Minnesota and Sacramento and Germany. Kenya, I love this. Egypt, I love this. Brazil, I mentioned we've got people all across the U.S. I used to go to San Jose once a week. Actually, I'm going almost about once a week too. So I see a nice, large people. Haven't been to Scotland in a little while, but I did a lot of work in Glasgow as well as Edinburgh. And I thought that was a beautiful place as well. So we're going to Argentina, beautiful place. Haven't been there in a while either. I always feel like I'm in Europe every time I go there. And yeah, we got a lot of us that are sitting here in Florida. Oh, Nice, that's a beautiful place. Haven't been there. RGB Tech, are you in Philadelphia? Because I have a cousin over there that uses RGB. So RGB, and are you in Philadelphia? If you are, let me know in the chat box. So we're going to begin in about a minute. So let's have some fun here. Also going to let you know that once per week on YouTube, we hold a question and answer session about your career. So if you've got questions about careers, want to know how to earn more, want to know how to get promoted, want to know how to get a job, want to know what skills you need to learn, please do that. And don't forget to like and subscribe to the video, assuming you're having a good time. So give me a hashtag AZ-305, or you can give me a hashtag Azure Solutions Architect Expert. When I see a bunch of them come in, I know you're awake, I know you're alert, I know you're oriented, and you are ready to get learning. Since I come from the medical world, I practiced internal medicine as a nurse practitioner prior to moving in tech a long time ago. I like to know people are awake before we begin. But we're going to have lots of fun. I'm super excited to do this. We're going to do lots and lots and lots of whiteboarding. Joby and Philly, that's a place I've spent a whole lot of time in, including going to graduate school there for 3 different master's degrees, actually, as well as living there for a little while. So I see these AZ things coming in. I see it. It's coming in from people all over the world. Let's get excited about our Azure Solutions Architect Expert Bootcamp. So we're going to begin by discussing the Azure cloud and how it's organized. And when we begin, we're going to make sure you completely understand what these are. We're going to talk about regions. We'll talk about availability zones. We'll talk about edge zones. And we're going to talk about point of presences. And I want to make sure we whiteboard it out. So when it comes to Azure or Azure regions, I want you to think of a large geographic area, like part of Europe or all of Europe or half of the United States or the country/continent of Australia. That's a region. That's a region. And inside of these regions, you'll see what you're going to have is going to be data centers, and they're going to be called availability zones. So you could have a region and you could have a whole bunch of data centers that are there. And what they have is they have dark fiber or fiber under the ground connecting these buildings or these data centers. And that is called an availability zone. So big region, you can see this large geographic blue area. And availability zones are data centers. Now, if you're new and you've not seen a data center, we're going to talk about what a data center is and why. We're going to talk about what a data center is real quickly. Do you know what cloud computing really is? Get rid of all the fluff and the mumbo jumbo. You're renting space in someone else's data center. So if you've ever stayed at a hotel versus bought a home, when you buy the house, it's your house. It's just you in there. And you stay in a hotel. Last week I was in Palm Beach. We stayed at a hotel in Palm Beach, even though I live close by. It was just a way to get away for a couple of days. And we stayed in this building that had multiple rooms in it or multiple suites in it. That was basically cloud computing. The whole big building, that's this big giant data center, and they rent you a little space in the data center or rooms. That is the basis of cloud computing. So a data center is a big room. And by big, I've worked on data centers that are 300 meters long and 300 meters wide. And what happens in these data centers, you bring in a lot of power, multiple megawatts of power, because and inside of there, you build your network, meaning your routers, your switches, your fiber optic, and your cables, so to speak. Then inside of your switches, you post your servers, which are actually doing your compute function. You plug in your storage area networks, your block storage, object storage, file storage area networks into these networks that already exist. You plug in your physical load balancers into these things. So you and you basically plug in your hardware firewalls, and you have a data center. You've got lots of air conditioners keeping these systems kind of cool. lots of power and a lot of power redundancy, because if a data center goes down or has a power failure, everything's going to be a problem. So you're typically going to have two power companies coming into the data center. You're going to have generators, backup generators, batteries, and that's a data center. Now, if you own your own data center, basically it's your building filled with these, and that's a private cloud. If you connect to a public data center and you share it amongst others, that's the public cloud, like AWS, Azure, Google, Oracle, or any of the other clouds that are out there. So big, giant region, area, region. Little building full of computers, well, big building full of computers, that is your data center, and that is the equivalent of an availability zone. Now, the next thing we're going to talk about is an edge zone. So what the heck is an edge zone, and why does it matter? I want you to think about it this way. I've got a lot of family members in Greece, even though I live in South Florida. You know, if I and I have a cloud running inside of my home, along with a very fast network that's running inside of my home, which is what I actually use for my students. I've got a 10-server OpenStack cloud. And in my home, the performance that I have accessing my cloud is lightning fast. Why? Because light travels at the speed of light along a fiber optic connection, maybe a little slower, but something related to the speed of light. And it's local to me, so there's no latency. And for things that matter performance-wise, they're in your building. It is the fastest thing. So if a company builds their own private data center, they will get better performance than the public cloud, lower latency, and they have more control over it. But the public cloud has so many wonderful things to offer. For example, it's scalable, it's agile. We can do things quicker than we could in the data center, which often gives us more of a competitive business advantage. So how do we get around the poor performance of the cloud? Latency based of the cloud. Well, we all use something that's going to be called an edge zone. AWS has their version of a local zone. So let's explain and walk you through what this is going to be. I want to whiteboard it out so you understand. So if this over here is the organization's data center or their campus, I'm just going to call it the campus. If on their campus they have a room filled with servers, it's going to perform really, really, really well because it's local. And let's say this campus is in, let's say, Palm Beach. We get nice weather here. It's kind of pretty. I like it here anyway. And let's say we're going to connect to a region, or I'm sorry, to a data center, and the data center is 1,000 miles away. So let's say Azure data center. We're going to call it availability zone. So we can use the cloud provider term, even though it's really just a data center. Now, from here to here, from my building to the data center, could actually be 5 milliseconds of latency, round trip time. Does that sound like a lot? It's not a lot. But if you're a bank and you're running an algorithmic trading system, and 1 millisecond can equal $300 million at the end of the year of net income, we can't afford to have that latency. So you've got two options. One is running things that matter in your private data center over here and not use the cloud, or there's something else that we can actually do. We can actually connect to a data center in between us and the main availability zone. So this is a local data center. And that's where we're going to talk about something called an edge zone. So let me explain to you why we use these. If this local data center called an edge zone, for example, is in Miami, and let's say this availability zone, let's say it's in Ohio, it doesn't really matter where they're at. The distance and the latency between Palm Beach, Florida and Miami is approximately 60 to 70 miles. So the latency is very low. So we might put latency sensitive applications in this local data center called an edge zone in Azure. And then we might put the rest of our stuff sitting in the data set, in the main availability zone or data center. So that's the purpose of the edge zones that we're going to be talking about. And we'll talk about a lot more. Here's the other reason you might want to actually have an edge zone or a local data center. Let's draw another version, because I want you to understand this from an architecture perspective. So let's say here's our local data center. I hate using terms like edge zone because I really want you to understand it. And let's say, for example, we have a fleet. Let's say these are self-driving cars. These are IP-enabled cars. Maybe they've got some machine learning, but these are self-driving cars. Now, if there's a car and there's traffic, we want to be able to respond to the traffic as quickly as possible. So we might point the cars to go directly to this local data center, otherwise known as an edge zone. And by reducing the latency going from the self-driving cars to the data center, the local data center, as opposed to going to the cloud provider's big data center, the availability zone, we can increase the safety. Every millisecond counts of latency when you're dealing with self-driving cars, or you're dealing with airplanes that are flying through the sky at 500 miles. So that's typically why we have an edge data center here. And they're called edge zones. So this is the way Azure would show it to you, where you've got this big, giant geography called an Azure region. And then we've got these data centers called availability zones inside the region. And then we have outside of the region these edge zones, which are local data centers. That's what we're talking about with regards to edge zones. So far we've covered the big areas, a region, the data centers and availability zone, and an edge zone is a local data center that is closer to you, that won't have all the features and functionalities of the full availability zone, but it's going to give you something. Now, the next thing we're going to talk about is the Azure Point of Presence. And Azure Points of Presence are what's used for content delivery networks, but I want you to understand what the concept of a point of presence. So let me explain to you what this actually is. I'm going to whiteboard a few things. I really want you all to understand it. So let's say we have a website. My cat Cindy loves tuna. So let's pretend there's a website that's called World's Best Tuna. And maybe there is. So potentially we're giving free advertising to the worldsbesttuna.com. But let's pretend there is a website called worldsbesttuna.com. And let's pretend that it's hosted in Japan on the internet service provider NTT, Nippon Telecom. They're a great internet service provider. I've worked with them in the past. And let's say that Cindy here is actually in Palm Beach. She's actually in Palm. So we've got my little cat here who's trying to Google how to get the world's greatest tuna.com. Cindy's actually attached to AT&T. So the AT&T is going to be her ISP. She has AT&T and Verizon, but Cindy is in this case going to be using the AT&T network. So what happens in internet routing is Cindy will go to her local internet service provider, and AT&T obviously does not have worldsbesttuna.com because in our example, it's hosted on NTT. So then AT&T, what it'll typically do will be to turn it over to another internet service provider. Let's just say it's BT. For whatever reason, I don't know how I flipped this thing upside down. Oops. Let's say it's on BT. So then AWS will connect to, say, BT. And then and I'm not sharing my screen, am I? So apologies for that. So let's say Cindy wants to get to the world's greatest tuna.com. And World's Greatest Tuna is hosted on NTT here. So what would normally happen is Cindy will connect to her local internet service provider, AT&T, and that will connect to another internet service provider, say BT, and then BT will hand it off to, I don't know, let's say Telefonica in Spain. And then Telefonica has a connection to the world's best tuna.com. So that's the way internet routing will ultimately happen. The routers will look, do I have a route to it? If they do, they'll forward it. If they don't, they'll drop it. So that's typically the way internet routing would occur, from internet service provider to internet service provider to internet service provider. Now, you see how this could potentially be fairly inefficient? And this means that AT&T is going to have a link to BT, as well as exchange routes via BTP, and BT would have to exchange routes via Telefonica, and Telefonica would be exchanging routes with NTT. And, when I started, that's the way these kind of things existed. And for the most part, this is the way routing actually works. Now, the cloud providers and the internet service providers have realized that buying a link from England to Spain, back to New York, back to Japan, probably not as efficient as it could be. So what you'll see is you're going to have these big buildings. Again, it's a data center, but in this case, the data center is going to be having much, much more networking gear than servers, because you can put whatever you want. And in this giant building, this is going to be the point of presence data center. What you'll see is you'll have the AT&T internet service provider bring a high speed, maybe 100 gig or a couple 100 gig connections into this building. which is called the point of presence. So let's say you'll have AT&T, and then you'll have Verizon in here. I'm just going to use their stock symbol. And then over here, you'll have, say, BT. You'll have BT. You'll have, say, Orange, all in the same building. French telco. And inside of that French telco, let's say we will have CenturyLink is another US one. Oops. Maybe we have Vodafone. So what happens, you have all these internet service providers all in the same building. So by doing so, all that's really necessary to get everybody to talk to everybody is to do something called a cross connect. And we'll talk much more about cross connects when we get to ExpressRoutes. So AT&T will run a cable, a fiber optic cable to the Verizon building, a Verizon router. Actually, they're going to run a couple cables. And then there'll be multiple cables to, say, from AT&T to British Telecom. And then there'll be multiple cables from British Telecom to Verizon. And then Orange is going to be connected to, say, Verizon. Hope you're seeing what's going to happen here. And BT is going to connect to Orange. And let's say we've got some links between AT&T and Orange. And for argument's sake, to make it simple, I'm just going to take these two off. So now in this one building, here's what happens. If Cindy's trying to go to the world's greatest tuna and she's directly in here, and she's going to AT&T, instantly in that same building, she hits the AT&T network. She sees, let's say it's on the Orange network right now, and she sees go straight from AT&T to Verizon. Verizon sends you back to Orange, and that's where the routing can actually occur in the same building, potentially, at least all those cross connects going from one network to another. So that's a point of presence. It's going to be a big data center. And this big data center is also going to have a lot of access to a lot of different internet service providers. Now, because Azure doesn't have the traditional point of presence, which is only internet service provider connecting to only internet service provider, the new world of these point of presences actually adds a content delivery network. So if, for example, inside of here, we put some caching servers over here, some caching servers that are going to cache frequently accessed web content, we can pop them in where the internet service providers are, because you typically have one of these buildings and everything else. And then you're going to have high performance web caching. So what's it all going to look like together? Now what we have here is we're going to have this big, giant geographic area. And inside of this big, giant geographic region, what do we have? Well, we've got those big, giant data centers called availability zones. And then what we have are these point of presence locations. So the point of presence locations are where all your internet service providers are going to connect to each other, and it's where we're going to put our caching servers. So why do we put our caching servers here? What's the point? Well, here's the point. So let's say this first point of presence, let's just say this, I'm going to pop in a location for it. Let's say this is Athens. Athens, Greece. Beautiful place. Spent a lot of time there. Highly recommend it. Let's say this other point of presence is, say, is going to be in, say, Palm Beach. That's in Florida. And let's say this other point of presence is going to be in Queensland. There's a Queensland, Australia. They've got a Palm Beach, Florida. They've got a Palm Beach in Queensland. It looks a whole like Palm. So why does this happen? What's the point of this content delivery network? And we'll talk much more extensively about content delivery networks. So here we've got a buddy of mine, let's call him Costa. And Costa is sitting in Greece. And Costa wants to go to a website which is stored on Azure. And Costa goes to this website, let's call it www.costaswebsite.com. And Costa goes to the website, and it hits the local point of presence in Athens. The website's hosted in New York City, for example. And the request is sent to this point of presence. There's a caching server there that caches frequently accessed content. So Costa goes to the point of presence in Athens. It's not there because it's sitting in the US and nobody requested it that day. And then it gets sent to the actual origin, which is somewhere in Palm Beach, Florida. Let's pretend that's where the data center was and where it was hosted. The servers will respond, or the object storage based upon what we have. They'll put the information into the point of presence. It'll respond. It'll run through that content delivery network, which is in Athens, that local caching center, that point of presence, and it will send it back to Costa. Oh, wait. Now, 10 minutes later, Spiro wants to go access this website. So now Spiro goes and enters that same website, and it hits the point of presence, and the point of presence says, I've cached it, and I respond to you. So now Spiro got the same information that Costa got, but he didn't have to traverse the internet going back to the United States, which means two things. One is we didn't have to pay for the transfer fees or the networking fees going all the way around the world. And these servers didn't have to respond a second time. So we've offloaded the work on our servers. It's also going to give us some DDoS protection, which we'll talk about when we get to security. So that is the way the content delivery networks. But, just because Costa, Spiro, and then say Nikolaos go to the Greek one and get it responded, what about Florida? So here we've got Aguilo. I'm sorry, the Greek names are what comes to my head first. So Aguilo in Palm Beach, Florida goes to the point of presence, and it doesn't have the website. So it goes back to the website where it's at, and that's good. That's what's called a cache miss. And then the response goes back, it's stored or cached in the point of presence, and then Aguilo gets this information. And then after Aguilo gets this information, Maria decides that she wants to get this information. She's also in Palm Beach. Poof, she hits the point of presence. Maria gets her information back, and everybody wins. So that is the point of the Azure point of presence. It's where the content delivery network is actually hosted. So I hope this makes sense to you. I also want you to understand, you see how these web servers scale because they don't have to do as much. You see how the latency is reduced. So I hope all these things kind of make sense. So that is the Azure cloud and the way it's laid out. And we're going to get into a lot of things and start talking about different cloud architectures. So I'm going to take a quick 10-minute break. Does anybody have any questions that I need to do? And then we're going to get in the next content. We're going to talk about what is a private cloud, a hybrid cloud, a multi-cloud, a hybrid multi-cloud. Because I got to tell you, 98% of organizations use multiple cloud architectures, which is why we're going to do what we do this first week and talk about which of these services you can use in multi-cloud, which ones you can't, and then still give you the certification training because I want you to win. I want you to pass the certification, but I want you to have good knowledge. Any quick questions there for me? No questions? I'm going to give you guys a second, see if you have any questions. Maybe hit the like button, maybe subscribe to the channel. We've got videos to help you with the AWS Solutions Architect Professional, the AWS Advanced Networking, the CCNA, and a whole lot of career things too. So maybe subscribe and hit the bell. We've got a couple of questions, very basic questions, which we'll ask. So is this like MPLS? No. So MPLS is a different way of actually routing or switching your traffic. So the best way I can describe this is normally traffic is forwarded via the internet protocol. And maybe Chris or someone from my team send a link to the BGP workshop that we did and the subnetting workshop. But the way normal routing is, I look in if I wanted to send a route to my neighbor, I look in my routing table, and your PC has a routing table. You can see your default gateway. And either it has a route to it, or it says, if I don't know where to go, go here. That's what a default route is, or a default gateway. Your packet hits the next router along the way, and the router looks in its routing table and says, do I have a route? If it does, it forwards the packet towards its destination. If it doesn't, it drops it. Then the packet gets to the next router and it says, do I have a route to this? If it does, it forwards the packet. If it doesn't, until it gets to the end of its destination. But that is done on the IP headers, the destination. Now, we will talk about potentially some encapsulation later, and if you'd like, I'll do some work on MPLS. I'm always happy to talk about MPLS. But what MPLS is, we take the IP packet and we pop it into an MPLS packet. And then instead of forwarding based upon IP address, we forward based upon the label. So if we have to get to if we're looking to go to the green label, it's going to look at its routing table and say, do I have a label green? And if the answer is yes, it'll forward it to the next hop. Why would we use MPLS? Well, it's a different way to forward our traffic. With MPLS, we can actually guarantee that our bandwidth gets delivered. Actually, we can do this with IP, with RSVP signaling. But MPLS can enable us to take some complexity out of our underlying network. For example, it may enable us to remove some of our BGP peering session. If we've got 10,000 routers running IBGP, we've got a fully meshed 10,000 routers. But if we can route traffic across our network with MPLS instead of IP, then we could have BGP peers that are further away from each other, and there's less work to do. That might be one reason. There's also ways that we can create virtual routers with MPLS, but no, this is really nothing like MPLS. But maybe I'll do a video on MPLS if you would like. Let's go to the next one. Is there a good way to get a developer account to test these environments? So Benjamin, if your goal is to be a developer, write your code and then try it out inside of Azure. Understand that whatever code you could develop to run on a virtual machine or a container, assuming you don't go proprietary, could work in any data center or any cloud. Now, if you're going to say Lambda functions or Azure functions or some of the serverless proprietary things, then it's going to change. Please understand, Benjamin, if you're an architect, coding is not part of what we do, nor is implementation or building it. So if you want to code, make sure it's because you're a developer or a cloud engineer or a DevOps engineer or someone that needs to code. But yes, you can absolutely sign up for a test account. And you get basically $200 in free credits that you can use for upwards of 30 days. And then you get about 12 months of access to certain other free services. So yes, there are some Azure virtual labs that we want you to do. Learn how to build some stuff, even though it has nothing to do with what we do as architects. We understand there's people that desire to be cloud admins that are here. And we also understand there may be people that desire to be cloud engineers or cloud developers or cloud database people, and they have to get hands-on. Plus, many of us like to get hands-on to actually reinforce some of the concepts. So I think it's great. So make sure you get our completely free Azure lab demonstration, so you can go through these labs on your own. I need you to understand cloud computing. I need you to have some degree of Azure solutions architecture by the end of this, but please go and do these labs, and they are absolutely there. Now, it's possible that, today it's $200, next week it's $100 or $500. These things change, but keep that in the back of your mind. All right, Chris, let's go to the next one. This should also cover AZ-104. We're covering all of it. The fundamentals that you would do in the AZ-104, as well as the solution architect. Still recommend you get a practice test, because the way cloud providers ask questions is a little challenging. So I recommend a practice test, but this will get you through the entire way of the solutions architect expert. But please also read documentation from Microsoft. That's what I would do. What's the difference between an edge zone and a point of presence? So if you'll recall, the large geographic area like a continent is called a region. The data center is called an availability zone. And we might want to pop certain things in that require lower latency, and we're going to put them in an edge zone. The point of presence is an internet peering point of presence, where one internet service provider connects to another internet service provider, and we have caching servers. So they're very different. In your edge zone, it's going to be your private stuff. In your availability data center, it's going to be private stuff. So things that are not exposed to the internet. These Azure point of presences are going to be for web stuff, which is going to be on the internet. Private network, internet, public stuff, internet. 80 to 90% of the technology that a business will have will not be exposed to the internet, and they can't be on a point of presence for that reason. Hope that answered your question. Is there a possibility that not all major ISPs would be available in a point of presence? Absolutely. So it's going to cost money to actually bring your connections to these point of presences. And generally speaking, there's someone that owns these point of presences, not the Azure ones, but like Equinix, and there's other companies that actually own point of presences. So you'd have to pay rent to put your routers in there, and you're going to have to pay to put your links there. So there's a strong possibility that somebody doesn't want to put there. So maybe, for example, let's say you've got a Greek internet service provider. Maybe they connect to a point of presence in New York. Maybe they do in San Francisco, but there's lots of other point of presence that they're not going to connect to in the US. Mufaz, I believe you're in Nigeria. So maybe there's a Nigerian ISP that connects to England, for example. And maybe one connects to somewhere in UAE, like Dubai. And maybe another one connects to Eastern Europe somewhere. So or somewhere that's in between, like Germany. So they could do that. But yeah, there's going to be lots of times where not all ISPs will be in all points of presence. Hi, Mike. Is it okay to use the CDN from the same cloud where you have your systems? Well, here's the thing. If you use a single content delivery network, when that content delivery fails, you've got nothing. There's a reason 98% of all businesses use more than one cloud. So I wouldn't recommend just using a single point of presence. And if you do like an NS lookup of Amazon, and if you were all do this, www.amazon.com, even though Amazon has their own content delivery network called CloudFront, the Amazon website is hosted on Akamai. They use the Fastly content delivery network. They use their CloudFront content delivery network, because the reality is, who in most cases at the enterprise scale would be crazy enough to put all their systems in just Azure or just AWS or just Google? Almost no one. Because all you have to have is a power failure, a control plane failure, or a security event that's major, and it'll take down the entire cloud, including all of the regions and availability zones. So you can use the Azure one, but I'd probably use others as well, because I don't like to put all my eggs in one basket and architect single points of failure into my systems. Who owns the POP? Well, there's lots of people that own POPs. There are people that are in the point of presence business, but they can also be network providers like AT&T or Verizon. So there's lots of different people that are in the point of presence business. In terms of regulatory compliance, do edge zones have the same limitations as traditional data center, considering aspects such as data sovereignty? No, these are internet service provider points of presence, which means they're wide open to the internet. There's absolutely, you're not going to be dealing with big security. But to be fair, Jose, I am not an attorney. And when it actually comes to architects like me that are designing compliance programs, we're always consulting attorneys. There's always attorneys that are involved in going through these things. So kind of make sure that, I'm not an attorney, but no, a point of presence is going to have nothing close to the security of an availability zone or an edge zone. Okay, there are no more content related questions, but a couple of career questions. The first one is, which certification do I need to get a job? There is nothing in any certification that will get anyone a job. We need to find out what career you want, and then we can give you all the skills that are necessary for the career. But a certification by itself, with the exclusion of the Cisco Certified Internet Expert, which is about 75,000 pages of reading, typically does not have enough for an entire career. It's a percentage of the career, but there's a lot of other skills. So join us on one of the free webinars where we'll talk about everything that you need to learn on Thursday. We're going to do one. It's going to be on Zoom. And, it's going to be based on architect. But if you want engineering, we'll tell you what skills outside of a certification you need to learn too. No matter what, you can all get the greatest jobs you want. I came from internal medicine as a nurse practitioner, and I've gotten people jobs every day of the week. So the point is, you can get any job you want. You just have to have the right skills and the right preparation. So join us for one of the career-related things, and we will help you get there. Okay, so let's get back to the content. So now what are we going to talk about? Well, we're going to talk about I'm going to briefly introduce the concept of the Azure VNet. Briefly, and then we're going to talk about various types of cloud architectures and their strengths and weaknesses. But before we do, give me a hashtag Azure Solutions Architect Expert. Give me a hashtag Azure Solutions Architect Expert. If you haven't liked it, please hit the like button. If you're not a subscriber, please subscribe. So I'm briefly going to introduce the Azure Virtual Network, and then we're going to do a lot more of it. So what is the Azure Virtual Network? Well, if you'll go back to my hotel example versus a house example, you build a 10,000 square foot house, guess what you get? You get a 10,000 square foot house, and it's all yours. But what if you took that 10,000 square foot house and chopped it up into like 5 different apartments, all in the same house? Well, then each apartment would be separate for the other apartment. If I've got client Medi in apartment 1 and in apartment 2 I have Apostoli, well, they're each in their own apartments and they can't see each other. It's private until they open their doors and walk into each other's houses. So the Azure Virtual Network, or the Azure VNet, is going to be your virtual private data center inside of the cloud. It's where your networking will be. It's where your storage will be. It's where your servers will be, and a lot of other things. So you can think of the Azure VNet as your virtual data center. And I always looked at it like this. I've looked at it like you've got this whole Azure thing, and you've got a virtual network and another virtual network, and many companies can have their own virtual network. Now, for security reasons, you may want to chop your Azure network into many hundreds, if not 1,000 different virtual networks, because we have a lot greater security in the data center than we have in the cloud. But you can chop your network into multiple virtual networks. That is what we're talking about. It's basically your hotel room inside of the hotel. So now let's talk about the various kinds of cloud architectures. Now, the first cloud architecture that we're going to talk about is the pure cloud architecture. Here's what this is. I put all my stuff in Azure, and everything is in Azure, meaning single cloud. Now, only 2% of enterprises will do this, and there's lots of reasons why. If I put all my stuff in Azure, and Azure has a network event, a security event, or a control plane, the thing that orchestrates the cloud, it doesn't matter how many availability zones and region I use, I lost everything. So how many people in today's world realistically use a single cloud architecture? 2%. And for the most part, most businesses should not use a single cloud architecture. Which then brings us to our next architecture, which is what's called the hybrid cloud architecture. And here we're going to draw the hybrid cloud architecture so you can see what that looks like. And here we have a hybrid cloud architecture. So we've got a building over here. Let's say this is our campus. And let's say on our campus, we have a data center. So we've got our workers here, and we've got our campus. And then we have users that are on Azure. Let's say they're on Azure Availability Zone 1, and I'll tell you why we do that in a second. And now we're going to have an Azure Availability Zone 2, which means we're going to spread our load across 2 different data centers in Azure, which gives us some degree of redundancy. And we're going to call this all Azure over here. So we've got half of our systems hosted in the data center and half of our host is in Azure. So let's think about what we get by putting our systems in the data center. Lower cost. Here's an example. I can buy a GPU, an NVIDIA H100 for machine learning. And if I get it from NVIDIA, it's about $35,000 to purchase, and I can use that for about 4 years. If I go to a cloud provider like AWS, they charge me $45,000 a year to rent that $35,000 GPU. Okay, well, over the course of 4 years, I can pay $180,000 to run that GPU in the cloud 24 hours a day, or I can pay $35,000 to do it in my data center and a couple thousand electric. So there's that. Now, if I've got servers that are big servers, I can buy a big server with like 128 cores and 4 terabytes of DRAM for about 200 grand, and that's going to cost me about $5 million to rent it over the course of several years in the cloud. Now, what's the other challenge of the cloud here? Well, there's this long distance between me and the cloud. That means latency. So what I might do is pop half of my systems in the data center and spread the other 50% of my systems on the Azure cloud. And why might I do this? Let's just say they're web systems for right now. I mean, they can be any kind of cloud systems, but I want you to understand. So if I've got a website over here, I'm going to have DNS. Let's pretend it's just the website, DNS, and I can send 50% of my traffic to the data center and 50% of my traffic to the cloud provider. We'll make sure there's some networking links between these two so the communication can occur. So here's what happens. If the Azure cloud fails, no big deal. I still have the data center. If my data center fails, I still have Azure. Now, what I can also do to keep my costs down is what I can do is I can run all my workloads in Azure. In my data center, maybe running Nutanix or OpenStack or VMware. And when my utilization reaches above my capacity, I could then shift the traffic over the cloud because I don't pay to use the equipment that I have in my own data center. I pay to use it for time in the cloud. So what we can do is a scheduled scaling policy called the bursting policy that if utilization of my data center goes over 85%, shift workloads to the cloud. So that's going to be the hybrid cloud. Now, why the hybrid cloud? Well, I'm going to have better performance because it's close to me. I'm typically going to have costs that are about 1/2 to 1/3 the public cloud for the systems I use there. On average, that's David Lithicum's number. He was Deloitte's head cloud strategist, and he teaches our AI architects, and I have a lot of respect for him. And those numbers that are in line with the numbers that I see. And so, 250% more expensive typically than the public cloud. So that's a private cloud because you can lose the data center, you can lose the cloud, and your systems are still up. And it typically gives better performance and lower cost. So that's a very common cloud architecture that you'll see. The next common cloud architecture that you'll see is going to be the multi-cloud architecture. And let's talk about why we would do this. So there's lots of good reasons to do this. So let's say this is Azure. Truth be told, for most use cases, Azure's got the best artificial intelligence options right now. So let's say this is Azure. And I can put half of my systems on Azure, 50% Azure. And you know what AWS has? They've got some really great infrastructure and a lot of extra features and functionalities that maybe some of the other providers don't have. So I could put half of my systems on Azure. I could put the other 50% of my systems on AWS. And I want you to think about this. If Azure's, let's say, best at AI and AWS has the most scalable infrastructure, then maybe I use some of Azure's toolkits for AI and I use some of AWS's infrastructure. So what we have here gives us what's called best of breed. We can use the best services from each cloud provider because Azure does some things better than AWS, and AWS does some things better than Azure, and Google does some things better than each one of them. So I can split my workloads across multiple clouds for the best features and functionality and potentially lowest cost. Or I can put 50% of my systems on AWS, 50% of my systems on Azure, and at the top end, let's say I use DNS or global routing or something. I'm going to use DNS because it's a lot less complicated than routing tables and BGP. So if I've got DNS here, and let's assume they're publicly available information, I have 50% of my workload going to Azure, 50% of my workload in this multi-cloud architecture going to AWS. They're all in an auto scaling group. If the Azure cloud goes away, poof, it's gone. Guess what happens? The traffic is rerouted to AWS, and AWS auto scales to be able to handle 100% of the capacity. So this is your typical multi-cloud architecture, more than one cloud. This is extremely common because for the most case, unless you're a business where technology doesn't matter, popping all the eggs in a single basket or a single cloud typically doesn't work. I told everybody the world would never go single cloud. I've trained all my architects multi-cloud for the last 4 years. And about 2 years ago, 98% of organizations switched. So now let's talk about your fourth architecture. And this is still pretty common. Now let's talk about why organizations would do this. So here they're going to have their data center. They're going to have their campus. And they're typically going to put their data center in the same building. And then they're also going to connect to, say, AWS. And they're also going to connect to, say, Azure. And this is an incredible solution. Well, obviously we'll need routers, and we're going to use more than one, obviously, for high availability purposes. But we'd have a router, routers, multiple routers. They're going to connect to each cloud provider. And the point is, we'll have access to systems on Azure and AWS and our data center. So we can put the things that run 24 hours a day, 7 days a week in our data center. Because when you buy something in the data center, it doesn't cost you anything to use it. So we put our most frequently running workloads in our data center. We put all the low latency things in our data center when you need the maximum performance. And then we split our workloads in AWS and Azure. For sporadic workloads like a website, things where we can really only build for what we need and then expand, the big places where we typically overbuild for, say, holidays, we'll put that stuff in Azure and AWS. Maybe Azure we use for AI. Maybe we use AWS for something good that AWS does. And this is called a hybrid multi-cloud architecture. So this is typically what you're going to see. So single cloud, 2% of enterprises use it. You put all your eggs in one basket, multiple availability zones, multi-region, and you hope for the best that your cloud provider doesn't have an outage. We've seen lots of outages at AWS, Azure, and Google over the years. Next thing that we typically see is the hybrid cloud, which is where we've got a data center plus a cloud provider. We can lose either one and still be good. Great architecture. Gives us the best performance because the local data center is always best performance. Often gives us the lowest cost because it's cheaper to frequently run workloads and workloads that run 24/7 in the data center, and put that agility, expandability stuff in the cloud. Next architecture is multi-cloud. Use more than one clouds. And that way, single cloud fails, no big deal, and you can use the best resources of each. And the last architecture is the hybrid multi-cloud architecture. That's what your banks are going to use, and businesses that, seconds of downtime cost millions of dollars a year. So those are going to be your architecture options. So now, I want you to think about this. If you put your systems on the cloud, how do you reach them? So if you're normally in a campus where we used to work, what's going to happen is, and I'll actually draw it out for you just so you can see how it works. I really want you guys to understand this. I know we're going into some systems that are a little bit, oops, that's not the way I want to do that. Bear with me a second. No. Here we go. I got another whiteboard I can work with. So in a normal environment, you're going to have, in your data center, you're going to have these big switches. They're going to be your core switches. And they're going to look like this. You're going to typically have these big switches, and these are going to be big and powerful routers. And they're going to have lots of speed, multi-hundred gigabit per second throughput that they're going to be able to handle. And this is going to be where your interior gateway protocol like OSPF or intermediate systems to intermediate systems is living. So that's going to be your network core. And then typically you'll have some flavor of what's called the distribution layer. And these will be connected to various core switches. And the reason we would have this layer over here is if we plugged our servers over here and the server went completely haywire, it went haywire on the center of our network and it can totally destroy it. By creating an additional layer called the distribution layer, we can isolate faults on this switch router before it hits the most vital thing. So that's typically the way your data center is. And then typically speaking, what you'll have is you'll have an access router, and that's where the users are going to be. And this is going to be the access layer. So this will be a switch, and this is going to, and what these switches will be wired to the desktop, and the user's PC will be plugged in here, user PC, and they will get plugged in. Your wireless access points will be plugged in, and your servers will be plugged into, say, more of a distribution layer switch that's over here. So we'll have our servers that are going to be plugged into these types of switches. And obviously, we'll be running routing protocols, and I didn't spell server correctly. S-E-R. So basically, our servers will be plugged into these devices. And when a user in the building wants to access one of these devices or the campus, here's what happens. The requests get sent directly here, and they get sent through their systems. Now, this is probably a millisecond or less latency. So this is going to give you really high performance. This is the way the systems work in the cloud. So when your systems are in here and all these switches are inside of your internal network and they all have private addresses, you have very good performance from here to here. Very good performance and very good throughput. Does that make sense? So this is going to be fast because it's all in the same building. Now, when you put your systems on the public cloud, by comparison, here's this Azure network. Here's your building over here, or your campus. How do you get your users and the campus to access the systems on the cloud? Well, if you put your systems on the internet, you're going to be compromising your security. So you can't put your payroll systems on the internet, your HR systems on the internet, your finance systems on the internet, and most of the things, they have to stay in your private network, which means you're going to have to connect these two together somehow. And there's going to be a couple of architectural options, but you could go through the internet here. Let's say this is the internet. You have this option. You could actually go to the internet, come back from the internet, but then how do you connect to your server, which is 10.1.2.3/24? You can't unless you tunnel through the internet. So we have to understand that you have to connect to your systems on the cloud. If you don't, you won't be able to manage them. You won't be able to use them. And there were some wacky workarounds with Bastion hosts, which are a security nightmare. You need a connection to the cloud because otherwise you won't reach it. So in the building, you don't have to think about it because it's there. But when you're hosting your systems 1,500 miles away, you have to think about it. So realistically speaking, we have two ways that we can do it. Well, actually, we've got four. I'm going to cover two because these are the ones that are in your exam. We can use what's called the private line, and I'll work through that. We can use an IPsec VPN, which I'll teach you through. And we can also use a SASE WAN or a software-defined networking WAN. As architects, we need to know that, but I won't be able to finish in 2 weeks if we keep going on all these technologies. But Chris or someone from my team, please drop a link on what is SASE and the software-defined networking so people can actually get through this and further enhance their training in architecture. So we can't go to the public internet. And what else can't we do? We can't use private IP addresses on the internet either, which means inside of your network where everything's going to be private IP addresses, they won't be reachable. Now, the only way we could make our systems reachable on the internet would be to NAT them all to a public IP address. So what does that mean? It means that 10.1.2.3 always equals 3.3.3.3 at all times. So I want you to think about this. If I have 100,000 servers, which I probably will in an enterprise, or 100,000 IP addresses minimum, can I create NAT to 100,000 different public IP addresses? No. Why not? Because we ran out of IPv4 addresses a long time ago. So we can't do that. Now, could we take our internal addresses and turn them into IPv6 addresses and connect to them via IP6 over the internet? Sure, but then we would lose our security boundaries, all of our demilitarized zones and all the other things. So we don't want to do it. So we're going to have two options. Option one that we're going to talk about is a VPN, and option two is a private line. So what is a VPN? A VPN is any time where we create a private network over a public network. So if we create an IPsec tunnel or a TLS-based tunnel over the internet, that is a VPN. If I create a layer 2 virtual wire on an MPLS network, that is a VPN as well. If I have an MPLS-based backbone and I dump all my routes into multi-protocol BGP and create virtual routing and forwarding instances, that's also a VPN. So a VPN, typically people mean IPsec tunneling, but anytime you create a private network over a public network, it's technically a virtual private network. And I've worked on all of them in my career as a network architect. So when we use a VPN, we have to do the following. We have to make sure that the person on the other end of the line is who they claim to be. My chief marketing officer and good friend Alonzo is on this stream somewhere along the line. If I want to have a conversation with Alonzo, I need to know a few things. One is I need to know that it's actually Alonzo. Now, if it's a video call, I can make sure it's him because I can look at him. but I need to know that Alonzo is who Alonzo claims to be. I also need to make sure that my message has not been changed. So in my old days, I would write prescriptions and I did deal with medical things. Imagine if I wrote a prescription, I had a person that had chest pain and I gave them 4 milligrams of morphine for their chest pain. And if a hacker changed that 4 milligrams to 400 milligrams of morphine, that patient would overdose and die. So I need to make sure my messages haven't been changed along the way. So I need to know that Alonzo is Alonzo, and let's pretend that Alonzo's the nurse right now and I'm giving him a prescription. I need Alonzo to get the right drug. I also need to make sure that if Alonzo's Alonzo, and I have lots of conversations with Alonzo, I called him twice today, but if I want to know that Alonzo's Alonzo, I need to know not only is he Alonzo, that the message didn't change, but if I tell Alonzo to do something, I don't want Alonzo to be coming back to me later and say, you didn't say that. So that's called non-repudiation. So when we deal with encryption, which is what we're going to use to create our VPNs, we're going to get that concept of identity verification to make sure we don't have what's called the man in the middle attack, where I think I'm talking to Alonzo, but this person, Caddy, is pretending to be Alonzo and they're not who they claim to be. I need to make sure those messages haven't changed, and I make sure that Alonzo and I can't say after the fact, we didn't say this. So kind of keep that in your mind. That's why we're using a VPN. So we're going to be using IPsec encryption. So in order to make this work, what do we need to do? Well, first we need the IP internet access. So let's kind of walk through this together. So here we have, in this particular situation, let's say I've got a campus over here. So let's say this is the Mike campus, and it's in, so this is Mike, and I am in Florida. We got Alonzo, who's over in Katy, Texas. I know where he's at. And it would help if I could actually spell. So Alonzo has an internet connection, which means he's got a router that connects to the internet. And let's draw the internet and internet symbols for those of you that are new to networking or diagramming. Is basically always a cloud. So if I can find my cloud here in PowerPoint, I will use it, but I'm not going to waste too much time looking for graphics. I am not a pretty graphics drawer, but oh, here we go. So here's the internet. We'll make the cloud look prettier. So now there's a router on Alonzo's side. He's connected to the internet. Let's see if I can find this. Okay, here we go. So I connect to the internet through my router. Alonzo connects to the internet through his router. And what we do is we create a virtual tunnel through the internet where we encrypt all data. All data. So this is going to be our VPN tunnel. So why is this special? Well, if my systems have private IP addresses, which are typically going to be in the 10.0.0.00/8 range, they're going to be in the 172.12.0.0/12, where my private addresses are going to be in the 192.168.0.0/16, and these are from the Internet Engineering Task Force Request for Comment 1918 of private addresses. I can actually pass my routing for private addresses over that VPN. And now I know that as Alonzo is Alonzo. I know that Alonzo is getting the right message and things like that. Kind of hope this makes sense to folks. So that's exactly what we're kind of talking about. Now, understand, when you send your data to the internet, it is not going to be guaranteed. If you have a gigabit Ethernet, a gigabit connection to the internet, you are guaranteed 1 gigabit to your internet service provider, but there are no guarantees beyond that. Meaning there's no guarantee that my traffic ever makes it to Alonzo. So I kind of hope that makes sense. So if I don't need a guarantee on my traffic, I can use a VPN through the internet, and that's going to give me private connectivity. And when you're dealing with this, there's a couple kinds of private lines. So I'll talk about the three types of VPNs that we can do, and then I'll draw it out for you. And then we're going to get into other stuff. So I can create a site-to-site VPN. And what is that? Well, I've got a New York office. I got a Delhi office. I've got a router at both offices, and we run a connection between them. That is a site-to-site VPN. Everybody in that Delhi office can reach everybody in that New York office unless I block it somehow with an ACL. Now, we also have what's called a point-to-site VPN. So that is me. So I leave my house in Florida. I visit my family home in Neapotomos, Greece. It's a beautiful place. I highly recommend Greece. So I go to my PC or my Mac, and I create a VPN tunnel to work remotely. That's called a point-to-site VPN. Now, here's the concept of a multi-site VPN. I've got my hub in, say, Florida. I've got an office in, say, London, an office in, say, Greece, and an office in, say, Lagos, Nigeria, and I create VPN tunnels to every office. So point to point, one location to one location. Point to site, me coming in. Multi-site, point A to point B, and there's another one. So let's say I have the Go Cloud Careers company that's sitting over here, and it's got its own virtual network. And let's say I've got a buddy that has a network engineering business, and we don't train engineers, we only train architects, but he's got an engineering business, and we want to create a VP, and I'm in the Azure and he's on Azure. We can create a private connection from his virtual network to my virtual network, and that's going to also be a VPN as well. But remember, we can't just go over the internet. And we can't go over to the internet because we need the security. We need the routing. Can't push private IP addresses across the internet. And we need to be dealing with our routing protocols. So that's what's going to happen. Now, how do you do this? Do you get to go over to the cloud provider and go inside of their building and go to their racks and rack a Cisco router or a Juniper router or a Palo Alto firewall in there and then be able to connect to that device? Well, no. So the only way you're going to create a VPN is going to be one of the following. You're either going to go to the Azure Marketplace and connect to a next generation firewall type thing that you can get from a Cisco, a Fortinet, a Checkpoint, a Palo Alto, or you're going to connect to the Azure VPN gateway, which is typically speaking what you're going to do. And you will use your router, connect to the Azure virtual router called the VPN gateway, and you'll create your tunnels. So it's going to look like something like this. And this, by the way, you would consider this is typically a multi-point VPN. Well, actually, if we're routing all three, it would be multi-point and a hub and spoke model, but each one of these are going to be point-to-point VPNs. So here we have one site in the upper right-hand corner that's creating that IPsec tunnel through the internet to the Azure VPN gateway. And here we've got another site that's also going to be connecting through the Azure VPN gateway to be able to reach these systems on the cloud. So Azure VPN gateways are going to be a router. So they're going to participate in the Internet Key Exchange, which is part of the IPsec protocols. They will help with authentication of the user, meaning Alonzo is who Alonzo claims to be. What'll happen is when I actually send my message, I'm going to send it with a hash. And for those of you that are not familiar with hash, this is like the coolest thing in the world to me. You put the letter A in, and let's say a 256-bit gibberish comes out. And every time I put the letter A in, the same 256-bit gibberish comes out. So that means that I can look at the gibberish that comes out and know the message has not been changed. One of the really cool thing is if you look at all the gibberish that comes out, you can't go back to the source and actually see that what the message really was an A. So it's one way. So, and where else might you use this? You might download, say, a Red Hat Linux CD, or a CentOS Linux CD, or an Ubuntu Linux CD, or an Oracle Linux CD. And you ever notice they have a hash that you can verify the integrity? That's what we're kind of talking about. That's that hash. And when I send packets over an Azure VPN or any IPsec VPN for that point, I'm going to have a sequence number on the packet. Packet 1, packet 2, packet 3. So I can't say that packet 2 was never sent. So now you're talking about it. So there's that. So if I use the Azure VPN gateway, it's going to have certain things. So how long does it take for me to set up a private line? First thing I got to do, I got to call AT&T and say, I need a private line somewhere. Then they got to provision their systems. Then they got to come to my facility and put certain stuff on the wall. And they got to do it on the far end. And that could take 3 to 4 weeks. But with a VPN, if you're connected to the internet, in seconds, I can create a VPN tunnel. So VPNs have the advantage in that, for the most part, everybody is already there. Everyone. So because of that, they're already there. So I can create an IPsec tunnel easy. I can create a multi-point tunnel to go to multiple places. I can create a point-to-point tunnel. But and the internet access is generally very cheap. So pretty easy to go. But remember, no guarantee of traffic on the internet. So if I've got a trading system where latency matters, I'm not going to use a VPN. If I have to have high definition video conferencing between the CTO that's sitting in, say, London and the CEO that's in San Jose, and I need it to work and work guaranteed, I can't use a VPN. I have to use a private line. So if your traffic doesn't matter that much and it's not critical, you can use a VPN. But if it really matters, you're going to have to use a private line. So what happens with these Azure VPN gateways is it's going to use the internet key exchange. So what happens, we're going to have both routers. They're going to have an internet key exchange that's going to go up. And this key exchange will talk about the algorithm they're going to share, the encryption site. And of course, now we're going to be doing things. So it helps us. So I kind of hope this helps make sense. And if we actually look at the way they do their VPNs, the VPN gateways on both sides of Azure are high availability, meaning they typically speak and create multiple connections to different availability zones. So they're there. But, and here's the big but, if you're going from Azure to Azure, that's not a problem. But this is where AWS and Azure, I don't like the way they teach this. So I'm going to teach it to you the right way because I come from a networking background. So if you're looking at, say, a VPN gateway, let's say this is the cloud provider's VPN gateway. And that VPN gateway typically creates a tunnel to 2 different availability zones. So here we've got a VPN gateway on the cloud provider side. Now, admittedly, this VPN gateway is what's called a high availability device. It is a logical device. So understand it's a gateway. It can't break because it's not real. It could exist on a whole bunch of different servers, what have you. But here's your campus. And over your campus, you're going to have a router. Now, your router over here, your router can go down, and the link between point A and B can go down. So you're going to need more than one router on your local end if you need high availability. So we're going to talk about how do you set up an Azure VPN very briefly. We'll take some questions, and then we're going to talk about private lines or ExpressRoutes, which is something I love to talk about. So how do you actually set up an Azure VPN gateway? Well, in this case, I actually have slides written down with instructions. Normally, I don't really create slides. I just have 1 or 2 lines on a slide that says, Mike, remind me of this. Because I teach most of this kind of from experience and being in these cloud situations for the last few decades. So in order to be able to set up a VPN, you're going to have an Azure account. You're also going to have an Azure subscription. You need to make sure you've got a VPN compatible device like a Cisco router or a Palo Alto firewall or a Fortinet firewall, for example. You're going to have a connection to the internet, and you're going to have a publicly facing IP address. And at that point, you're going to have to determine what your routing is. Which subnets do you want to push to the cloud? What do you want them to know about? So how do you do it? You're going to sign into the Azure portal. No big deal. You click virtual network. You go to virtual network. You click create. You fill in whatever you need for your systems. You review, create it, and run a validation test. And once it's done, you deploy your VPN, and it is very, very simple. So let's see if anybody has any questions. And if now might be a good time to maybe hit the like button, for example. Preb, I know you. Hi, Mike. How would you leverage data center and multiple cloud providers to achieve 6 nines of uptime? Just an overview. So, most organizations will never be able to achieve 6 nines. In fact, Preb, most organizations will not be able to achieve 5 nines. So, let's talk about what goes into a 5 9 system versus a 6 9 system. Because 6 nines, which is 52 seconds a year, there's about 10 of us in the entire world that could design it, maybe fit between 10 and 50 people. And they're going to be the people that have been your lead architects at Cisco or Juniper. There's very few. And but how would you do it? The first thing that you would have to have is multiple power companies coming into every single data center you have. And to get to 5 9s or 6 9s or clouds, you're probably going to need to use at least 3 clouds to get to 6 9s. You're going to have redundant networking across a large number of internet service providers. Every network device that you have is going to have multiple power supplies going to different power outlets. For example, multiple control modules or brains in your routers and switchers so one can fail. Multiple line cards, which is where you plug your cables in, and they're all going to have to be there. Your data centers will have redundant power. They will have generators. They will have redundant backup generators. They will have battery packs. You'll need to have redundant cooling systems in each of these clouds. Now, you're probably going to need to use all 3 clouds with at least 2 availability zones per cloud and 1 to 2 data centers to get to 6 9. Now, the technology at this point is the least part of it. And you're going to have really good change control procedures. You're going to have very good testing procedures, because you can have the perfect system in the world and you can allow CrowdStrike to come in and modify your systems and they can take you down. If you connect to the internet service provider and they send you bad routes and you're not route filtering because your governance policies aren't good enough, they'll send your traffic to a black hole. So you're going to have very strong operational procedures and very strong processes. And you want to make a change, and it's going to have to get approved by 50 people and take 2 months to determine if the change is there. That's what goes on. So when you need to go a 5 9s or greater, nuclear power plant, certain banks, you're not going to be using like this DevOps. Let me try new code. You're going to develop your code. You're going to test it for 3 to 6 months. And then you're going to deploy it, and you're not going to redeploy it for a long period of time. And then when your people develop it, you're going to test it, you're going to stage it, you're going to push a percentage of the traffic. So typically speaking, 6 9s, figure 3 clouds plus a data center or 2. Really good networking people, really good security people, really good change control. But I've designed systems that cost well more than that cost multi-billion-dollars to get to 5 9s availability, and 6 9s. I've never seen anybody be able to do that. Though some of us have tried, and we've got a little better than 5 9s, but that's pretty tough. You have a Windows multi-point server in your local network. Can you connect to Azure Cloud? Well, you can easily connect your system to the Azure Cloud. So if you really wanted to do it, what I would do would be to get rid of the Windows on the server, smack a hypervisor on the server, say VMware or Linux KVM. In one of those virtual machines, you would have to have the routing software that could connect you to the cloud. In another virtual machine, you could have your Windows server, but you're going to need a router that's going to connect you to the Azure cloud. Unless you're trying to do just a basic remote access VPN. Otherwise, you're going to need a router. And you can get routing software to run on Linux. You could either buy routing software from like a Cisco company because they'll sell the routing software. If you're really good with Linux and wanted to create a router, you can get a Linux router. You could run the Bird routing daemon, and then you can set up BGP routing, etc., and IPsec tunneling. Or you may be on your server, you've got one system that's running routing software, another one that's running a VPN. So you could do it, but there's a reason we use networking devices for networking, like routers and firewalls. But you could do it on your server. But I'd probably get rid of the Windows on it, and I would turn it into more of an industrial routing server. And in fact, I have my students create VPN concentrators on Linux and Active Directory. You might want to have. So that's what I would do. Like if I had a server with enough cores, I'd create an Active Directory server for identity and access management. I'd create a VPN server. I'd create some Linux routers and set up some routes, but not just traditional Windows stuff. You could do it from a remote access perspective, like you would to sign into work, but not a real server where you're going to be passing routes, etc. Good question, though. Is it advisable to use Cisco Packet Tracer given that you like its design for simulating network labs in Azure, or are there better tools? Here's the secret. All cloud computing is running space in someone else's data center. Every time you see a new feature, Jesus, it's really nothing different. So a couple of years ago, AWS said, wow, we allow private IPsec over a private line. Well, guess what? Cisco did that back in 1998. None of this stuff is new. In Cisco, we had the concept of a private VLAN many years ago. Can't even get to half of the stuff on the cloud. If I wanted to learn networking, what I would do is I would get myself a good server. I'd probably use EVE-NG, the professional version for it, but Cisco has Packet Tracer. But you're going to be able to do much more sophisticated networking labs off Azure. All the cloud providers are about 20 years behind in networking. They have very limited networking things. But if you want to learn networking, get an EVE-NG server. That's what the industrial people use. Get a Cisco Packet Tracer server, or get a rack of routers and switches and turn these features and functionalities on. That's what I would do. Go to the next one, Chris. Good question there. If you can't go back to verify the hash I put, does that mean it returns different digest? No. So, well, there's two ways you could verify a hash. So if you're going to download from a file, there'll be a hash, and you'll verify the hash. And meaning, does your hash on your file equal the hash that you were sent? If it's the same, it's good. If not, you throw it away because it's been corrupted. Now, FB, when we have these IPsec tunnels, the hashing happens automatically. These systems are verifying the hashing for you. Bad hash comes in, it could tear down the connection or something like that based upon the way it's set. So it's automatically done for you. You're not going to have to go back and verify it. Trying to see if there's any more. If not, we'll get back to the topic. Okay, no more questions. So someone asked my advice on the CCSK. So here's what I would like to say, and I'd like you to think about. When it comes to a certification, when it comes to any career, what you really need to do is figure out what you want to do. Like, what is my actual goal? And then you need to figure out what skills you need to get for that goal. And then you need to look at what certifications match that goal. For example, if you're an architect, an Azure Solutions Architect Expert looks good, even though it has very limited architecture. TOGAF 10 looks good, for example. So they are architecture things. If you wanted to be an architect and you get something in development, or you get it in DevOps or SysOps or engineering, that doesn't make you look like an architect. It makes you look like you studied somebody else's career because you did. So for the person that asked questions about the CCSK, for the people that asked about other ones, please join us on the How to Get Your First Cloud Job webinar. We will happily go through one. We have one on Thursday, but maybe I'll do a couple extra in the next week or two because we may have a lot of people that want to understand, because we have to understand what the role is. And I can tell you the skills that you need for any of these careers, and I'm more than honored to do it. But don't just take certifications. In fact, if you've got the wrong certifications, you may have to remove them from your resume to have the hiring manager take you seriously. Because if you wanted a surgeon and you walked into the surgeon's office and it said dog walker and it said baker and it said chef, you'd probably be scared and have another surgeon do your surgery. Well, it's the same thing when we hire people. We look at their education, we look at their background, we look at the things on their resume, their LinkedIn profile, and everything that goes there. So kind of hope that matters. So you guys want to learn how to become a cloud engineer? 10 one of these free question and answer sessions will cover it. You want to learn how to be a cloud architect? We'll cover it. You want to become an AI architect? We'll cover it. Want to become a security architect? We'll cover it, but we just can't do it while we're doing these. But I'd be honored to help you. So now we're going to talk about a private line. But before I talk about private lines, give me a hashtag Azure AZ-305. Hashtag Azure-AZ305. There's a whole bunch of you guys, so I'm kind of hoping we can get a whole bunch of Azure AZ305s. Maybe a bunch of you guys can give this content a like or subscribe to the channel so you can see us again. I got a lot of free stuff coming for you down the road. So hopefully that works. So if, by comparison, I didn't want to leverage on the internet and I needed to know that my data was guaranteed to reach point A to point B, well, then I could do something about it. I often thought of the VPN as kind of like flying on a traditional airline, because you may have a flight from Palm Beach to New York. It's supposed to go at 7 p.m. at night. It's supposed to take 2.5 hours, for example. But your flight at 7 leaves at 11:30 at night because of whatever reason, either weather, whatever reasons the airline made up. And then it took a long time to load the plane, and that delayed you an additional 15 minutes. And then the airline crew's been working too many hours, so they've got another crew. And by the time you're done, you're 10 hours late for your 2-hour flight. That's kind of like the VPN. Now, if I had to go and I had to be sure that I can go from Palm Beach to New York, and I had a private plane and I could drive my car to literally the tarmac and somebody else would park the car, I could jump on it, not have to get into a bunch of security lines or queues, fly straight to New York, and I could be picked up on the runway or pretty close to it. That 2.5-hour flight is going to be 2.5 hours. Now, in networking, when you need a guarantee, you get a private line. So a private line is, realistically speaking, a wire that you get, kind of like my old iPhone headphones, which no longer work because they changed the port on it, but it's like buying a wire from point A to point B. So that is a private line. And when you buy a private line, it is your wire. If it's 1 millisecond of latency across the wire, it is always going to be 1 millisecond of latency across the wire. If I buy 100 gigabit per second, guess what I'm going to get? 100 gigabit per second minus whatever the overhead is of the IP headers, Ethernet headers, what have you. I've got reliability. I've got guaranteed speed, guaranteed performance, much more like that private plane versus we all know what it's like to travel on a commercial plane. Now, when we have cloud providers, they really don't like to tell you what they actually have. They make up funny names. And why? It's really hard to sell you 25-year-old technology or 30-year-old technology like a private line, actually more than 30-year-old technology, and make it sound exciting, right? It's just a wire. So AWS marketing department comes up with the name Direct Connection. Google calls it a direct interconnect, and the marketing geniuses at Microsoft call it an ExpressRoute. Who cares? It's a private line, but understand this. So if you need that guaranteed performance, you're going to do it. Now, we have the ability to, and I'm going to walk through how this works. I'm going to draw it out for you. We have the ability to use more than one. So I'd like you to think about this. I can have 2 disparate private lines. Let's say I've got 2 links over here, the top one and bottom one. I can run a BGP policy on one link and another link to load share without getting out of order packets. And I do it all the time. But I could also put 2 of these wires together and bundle, say, 4 of them together. So now instead of, if I had 4 10 gig links, I can bundle them together, 4 of them, and get a 40 gig link. One of these links fails, I still have 30. That's going to be called a link aggregation group. I think Azure calls them link root groups, but if you're familiar with port channel or ether channel on Cisco routers, or link aggregation groups, which is a protocol you might use on a server, that's really what we're talking about. So kind of keep this in the back of your mind. That is ExpressRoute. That is direct interconnect on Google. So it's going to be a wire. Now, you're going to have lots of opportunities for wires. You're either going to get a gigabit connection, which is the smallest link you're actually going to get. Now, you could get what's called rate limiting on your internet connection, which means they can limit you to 50 megabit per second or 100 megabit per second or 200 megabit per second or 500 megabit, which is, but you're still buying the 1 gig wire. They're just only letting you use a percentage of it. You can also buy 1 gig links or 10 gig links. And of course, they'll rate limit you, maybe let you have 2 gigs or 5 gigs. So we have that. Now, if we're going to connect to the cloud, I've got to be able to exchange my routing, right? Like, how do I reach certain things? So I need, what I need is what's called a routing table. And if you're going to build a routing table dynamically, you're going to use the routing protocol BGP. While in a VPN, you could use static routes. I wouldn't. I use BGP. Or you could use dynamic routing protocol BGP with a private line on the cloud providers. You must use BGP, which means you need to know BGP. So Chris from my team, pop a link to the last 8-hour BGP session that me and Mark Milovanovic, 2 CCIEs with about 35, 40 years of networking experience, put together. So let's now look at how these systems actually work. So here's the way these private lines actually work. In a traditional private line, let's say this is New York, and over here we have, say, San Francisco, and we buy a private line. We're running a wire between them. This simple stuff. Normal private line. Now, unfortunately, it doesn't work quite this exactly the same way when we're dealing with the cloud provider. So if the one was New York and one was Miami, the way it works with the cloud provider is going to be as follows. Bear with me, I'll show you. Your router is going to get a link with another router of yours, which is going to be sitting in the ExpressRoute location. We'll get to the name of that in a minute. But you're going to buy a link to this location. And what this device over here is called, it's called a provider edge. It's called the customer edge router, because you're connecting to this location. AWS would call it a direct connection location. Whatever the case is, we're going to have that location that we connect to. Let me show you. Let's build this. So you're going to get a connection between your office and this direct connection location center. What do they call it? Hold on 1 second. Actually, look up the name. I can never remember the name these funny marketing people come up with, but it's all the same. And hold on, let me bear with it. So this is going to be Azure. So you buy this connection between you and the customer edge router. Now there will be a Azure switch that's sitting here. And this is going to be like a Cisco switch or a Juniper switch, but this is going to be the provider edge device. And what'll happen is you're going to buy a link from here to here. And you're going to need to have a cable run from here to here. This cable between your stuff and the Azure stuff is actually called a cross connect. So what'll happen is you'll buy a connection from here to here. You're going to have to get explicit permission to run this for them to run this cable between your device and their device. And then your information is backhauled, and it's going to be that. It's going to be like backhaul. HA. All the way to the Azure network. Works the same on Google, works the same on Cisco. And typically speaking, they're going to keep your traffic segregated by putting you in a different VLAN or something along the way. But it's a private line, but sort of, but not really. You're buying this guaranteed link from here to here. You've got guaranteed bandwidth from here to here, and they guarantee your bandwidth from here to here. That is the way these direct connections actually work. So Let's talk about some features and functionalities of this. It's going to give you private line, meaning dedicated performance. Azure also supports something called bidirectional forwarding detection. Okay, and what is this? Well, for those of you that are familiar with fiber optic connections, and we're going to be using a fiber optic connection, there's a send laser and a receive laser. So I got these two lasers, one's pulling information, one's sending information, send, pull, send, pull, send, pull, send, pull, that kind of thing. And if one of these links goes down, like the send link, but we're still receiving information, for a period of time, the routers may not know that that link is down because half of the link is up. So imagine me having a call. I wanted to call Alonzo. I call Alonzo and the call's up, but Alonzo can't hear a single word that I'm talking about because he can talk to me, but he doesn't get any signal back. We've all had that one-way audio on a phone. And after you've spoken to somebody for 5 minutes and they don't know anything that you've spoken about until the call drops, that's what we're talking here. So ExpressRoute or any of these things support this bidirectional forwarding detection, which means if one of your lasers goes down, they will break the link. So you can route over your backup, whether your backup be a VPN, for example, or another private line. For redundancy, these ExpressRoute circuits have two connections to Microsoft Edge routers. So you've got some degree of redundancy in your connection. But if you're linked to that direct to connection environment or that ExpressRoute environment goes down, it doesn't matter if they've got two links back because you can't reach it. So that puts us back into the same situation. I'll draw it again because I want you guys to get it architecturally. We have to plan around the cloud providers. So here's what they're basically saying. They're basically saying, here, our router is going to connect to, it's going to create two links back, which is great. So you connect to that direct connection location and it's going to have a link to two different parts of Azure. This is great, right? But now you've got your campus, your router, and you got this, and you're connecting to this provider edge router over here. This is your local router. And this is your customer edge router. This is your router. This means this is your customer edge. This is the provider edge device. And you've got a connection. And so you've got a connection to say here, which is going to go back to these two devices. If this router fails over here, or this link fails over here, you've got nothing. Deep with that, Zaba, Bootcamp, whatever country you're in. I mean, so you've got nothing. So yeah, it's great that the cloud providers do this. It's really great. But if you don't have any redundancy here or any redundancy here, you got nothing. So keep that in the back of your mind. So when we connect to these things, these connections can kind of be routed to different places. So when you connect to ExpressRoute, it connects to three different things. It connects to your private stuff, the stuff that's in your VNet. But there may also be some public Azure services which you want. You'll be able to reach them through these kinds of things or other Microsoft services. So understand, you get this private line. It'll give you private connectivity to your things, and it's going to create this virtual connection for you to be able to research other things that are not inside of it. Here's another version that someone from my team actually drew for me to make it look good. Here you can see we've got the customer's edge network. We connect to that. We connect to our router. It hits the partner edge, and then it's going to create two different virtual links back to different parts of Microsoft. You can see some of these things are going to be public and some of these things are going to be private. And that's really what we're talking about. So how do we create one of these circuits? Well, generally speaking, it's going to be the following. And you're going to go to this environment. My team drew out these instructions. So you're going to go to the portal. You're going to click create a resource. It's going to be networking, and you'll pick ExpressRoute. You'll select the ExpressRoute. You'll correct all the information, and you'll fill in what you need to do your correct SKU. But you're also going to need to get a letter that gives you that permission to go from your device to their device. That's that interconnect or that I was trying to describe. Okay, so we discussed ExpressRoute, which is great. Now let's talk about the next thing. We're going to talk about a network interface. So, what's a network interface? If you've ever looked at your computer, you may notice that it's got an Ethernet port where you plug the wire in. That is a network interface. You may have a server and it's got 4 or 5 network cards in it, right? They're network interfaces. So a network interface is just a connection into the network. So you're going to have your virtual machines and it's going to have a network interface in it. So a network interface will enable your virtual machines to connect with the network, whether they be internet network, Azure resources, or what have you. Now, generally speaking, every device is going to have one network interface, but you may need more. Now, when you bring up a system on Azure, in most cases, you're going to be getting a public IP address until it's reassigned, meaning it's going to be reachable from the internet. If you don't want your system reachable from the internet, and you're not going to for 90% of your systems, don't put a public IP address on it. Typically, you have to pay for these public IP addresses anyway. Private addresses for the stuff internally with private routing. Public IP addresses only for the things that need to be reachable in the internet. Now, let's think about it. If I put a public address on you and you have routing to the internet, I can reach you. Do you want to be reached all the time? I don't. But if I'm sitting in my house and I close my blinds, you don't know what's going on inside of the house, especially if I put some thermal insulation so you can't use any kind of thermal way to look into the house. So kind of keep that in the back of your mind. Businesses don't want their stuff. So kind of keep that in the back of your mind. So maybe it's worth drawing it out. I want to make sure you kind of get the concept of what it is. So let's say we've got a server over here. Typically speaking, your servers kind of look like these kind of things. They look like these giant pizza boxes are thick. And in the front of your server, if you've not seen your servers, well, maybe we'll just kind of try to help you out with that. Because if you don't understand what these things are. So typically speaking, in the front of your server, you're going to have a couple of hard drives that are sitting here. These will be your hard drives, which the hard drives in your servers, typically speaking, are going to be pretty fast compared to these virtual hard drives. So this is you're going to see in the front of the server. In the back of the server, you're going to see a bunch of these little Ethernet ports. These are going to be your network interfaces. Now, when we get to virtual machines, I'm going to peel back the hood. I want you to actually understand, and these are going to connect to your switch. These and actually, they're going to be connecting to different logical switches in many cases on different subnets. Now, it could be a different VLAN or it can be a different switch, but typically you may have the server connect to one network over here, potentially a network. This is what's called a dual home server or a 3-home server. So there's that. When we actually get to discussing compute and virtual machines, what I'm going to do is I'm going to take you back into my data center and we'll go into the VMware environment and we'll show you what these servers look like from a computation perspective and a core and a DRAM. And maybe we'll create a virtual machine so you'll actually know what an Azure virtual machine actually is. Understand, no network interface, no connection to the cloud. So there's that. Next thing we're going to talk about is storage, which is a topic I love, but that's going to be a natural break before we go into storage. So my recommendation is we take 5 minutes, because it's only been a few minutes, to answer some questions, and then we start talking about storage. So let's see if anybody has any questions on the ExpressRoute. We're introducing these topics now, and we're going to get into much more details as we get through the weeks. Is the correct connection made in a point of presence? Well, the way these companies describe point of presences, the answer is no. But is a direct connection effectively an internet peering point or a private line peering point of presence? The answer is yes. So we have to define what we mean by point of presence. But if we're looking at the way Azure defines a point of presence, which is where they put their content delivery network, no, they are not made in a point of presence. If we are looking at the traditional networking world where you got a building filled where internet service providers and network providers come in and they do handoffs to other providers, then yes, this is a point of presence, but not the way Azure calls it a point of presence. Maybe not. Maybe no others, which is okay. We can start talking about storage. I love storage. Okay. So there was a question from Gaurav, AZ305, the first step for a cloud study. If not, please advise how to start a cloud career. Well, I'm going to invite you to the webinar, but I want to be very clear. You need to know your destination. Why? If I'm an architect and I want to be a cloud architect, for example, I have to design systems to optimize business performance, which means I need to know how the underlying technology works. I need to understand how business operates. I need to understand how business processes work. I need to know how to evaluate an organization's business, its business processes, its goals. I then need to go create an architecture team to come in and evaluate that organization's information. After I understand their current information, the business architecture, I need to figure out how the business needs to operate in the future with the client. I need to evaluate their technology with my team of 15 to 50 people that I need to lead. Then I need to work with that team to create a new design. We've got to document the design. We've got to respond to RFIs, RFPs, RFQs, what have you. We've got to give multiple presentations. We've got to help sell the design. We've got to create a governance structure, which are 90% business things. By comparison, if I'm a cloud engineer, remember, architects don't touch the technology. If I wanted to be a cloud engineer, I'd have to be an expert on building. Now, building means I would have to understand not only how to do all this stuff on the cloud, but I'd actually have to understand how to work with Windows and Linux systems if I wanted to be an engineer, which means I'd have to be able to install systems, patch kernels on Linux, install applications. If I wanted to be a cloud engineer, I'd need to know Python. I'd need to know Terraform. I'd need to know Bash shell scripting. No, you didn't hear me mention a single one of those skills for the architect because we don't do any of that. But that engineered something different. Now, if you wanted to be a developer, it would all be about your software development code. So please join us for a webinar. But there is no starting point. The starting point is knowing what you want to be. Want to be an airplane pilot? Then you got to learn everything you need to do to fly a plane and get licensed, which is different than what you needed to be a physician. So I do want to help you, but we need to know your goals first. 99% of the people that have not gotten a job after 3 to 5 years of training is because they're training for the wrong job. So I want to help you, but I can't do that in 5 minutes here. But we're going to have a webinar on Thursday where we're going to cover the architect role and everything you need to do for that. And I come online at least once a week where I'll discuss careers. Come and ask a question. So subscribe, hit the bell to be notified, and you'll be notified every time we go online to answer career questions. And I do want to help you. So let's get into storage. But before we do, give me a hashtag Azure AZ305. All right, let's talk about storage on Azure. There's going to be a lot of storage that we're going to talk about. And now we're just laying the fundamentals, and then we're going to talk about it next week through the way we would actually use it. We'll go through Azure's recommendations, Azure's recommended training approach, the Azure well-architected framework to put the pieces and parts together. But we'll typically be talking about queue storage, which is message queues, and we'll talk about what they are throughout this time. I'll talk about table storage, which is more how you would store your data in a semi-structured environment or structured environment, like you actually would on a database. We'll talk about object storage, which is a type of storage area to network, which we typically use for backup and archival purposes. Azure calls it Blob. Google calls it cloud storage. I mean, it's silly. And AWS calls it S3. It's object storage, and we'll talk about object storage and what it is and why organizations use it. Then we'll talk about file storage, which is what you typically have on your computer. It's also what you would do if you had to have 5 systems run things on the same time, which would be server message block under Windows or NFS under Linux or Unix. And we'll talk about disk storage, which is the disk that's sitting inside that server, typically speaking. So we're going to go through your storage environments. We're going to start by introducing these kinds. So block storage is the first storage area network we're going to explain before we actually get into anything. Block storage is a type of storage area network, meaning it's not stored on the computer you're using. It's over the network. We have our data, and it gets broken down in these little things called blocks. Now, that's pretty interesting because your hard drive breaks information on block, but that's local to your system. Block storage is over a network, so kind of keep that in the back of your mind. It's going to store your data in blocks over a network. Each block will have a unique identifier, which is going to help you in finding the block. But here's the key. With block storage, your server's here. Your storage is here. And as long as you've got IP connectivity to your storage, you can use it. So when we have virtual machines, which we'll talk about later, and we have containers, they need a hard drive, right? To boot up and do their stuff. And there's a couple places we can put it. We can put it on the server itself, which is going to be the fastest storage we have. Now, if you put it in your server in your data center, no big deal, right? You can access all the information. With these cloud providers, with these cloud providers, you have to understand that. I forgot what I was talking about. With these cloud providers, you have to understand that if you terminate like your virtual machine, you're going to lose everything and you'll have nothing. So what we need to understand here is we need storage that's what's called persistent, not ephemeral, meaning when you delete the server, you're going to be there. And the only way we can do that in the cloud is block storage. So there's that. So understand that we use it because it decouples the server from the storage. And even though block storage is horribly slow, I mean, it's really slow, it's the fastest we can have in the data center. So let's actually look at what this is. I want to draw this out for you. And we can show you why we're doing it. So let's say here's your server, and I want you to see the limitation of it. And let's say I've got this server, and let's say this server is really powerful, and I can put like 15 or 20 hard drives in it. Now, most servers themselves don't store that many hard drives. Most of them are more optimized towards more CPU resources. But let's just say I've got my server, and on my server, I've got a certain number of hard drives that I can pop in here. These are all going to be hard drives. Now, this has got a lot of storage. Does anybody see a problem? At some point, I'm going to run out of storage in the system. And no matter what I do, I can't add any more hard drives. There's no more PCIe slots on the motherboard, or there's no more SATA, SAS type connections that are sitting on the motherboard for me to use. So there's that. And now this is a server that's pretty big and thick, right? Now, because it's big and thick, it's going to take up a whole lot of rack space. So what if I wanted to use a smaller server, and instead of worrying about hard drives in the server, I wanted to focus on CPU performance and memory because I wanted to create a lot of virtual machines. So now, instead of having this, I can take this server, I can turn it into something which is what's called one rack unit, which means it's the size of a pizza box. If any of you are familiar with a pizza box in, say, the United States, very small, very skinny. And what I can also have is I'm going to have all this stuff plug into my network, right? Because the systems won't be reachable. This system plugs into the network. Now, these used to be a different network called fiber channel that we would use, but not in today's world. And now all of a sudden, I've got these machines over here, and these are storage area networks. These are going to be RAID arrays. And inside of this thing, I can put, let's say, I'm going to put some hard drives in here. And I want to show you why we're going to do this. And I want it to make sense to you, why we use block storage, why the cloud providers love this, because it's not fast. So why do they love it? Why are we using it? And why would we use it in a data center anyway? So let's say we've got these things. Bear with me. Let's copy some of these things. Okay, so now I got this big storage box. This is block storage. So now I've got this box full of hard drives that I can stick anywhere in my system. And now all these, and now this server itself, this server could have 50 virtual machines. They can now store all their information on this storage area network device. And you know what happens when I run out of storage? Really no big deal. I just add another one of these storage devices and I plug it into the network. So by decoupling the storage architecture from our compute infrastructure, we can scale even better. Want to hear something even more exciting? What do I need to back up if I'm the cloud provider? Really? I need to back up this device and I need to back up this device, and I've backed up everything. I only have to back up my storage. So there's that. So kind of keep that in the back of your mind. That's why we're using block storage, because it decouples or it separates my compute from my storage. I can store these blocks of data anywhere I want. My server won't know. I can add this capacity anytime I want, and the server won't know because it's stored in blocks. So very simple to maintain, highly scalable infrastructure. Now, the next kind of storage we're going to introduce now is object storage. Now, object storage is more that cloud type storage that you typically think about. AWS calls it S3, Azure calls it Blob, Google calls it cloud storage. This is very different storage. Basically, what happens here is we've got our data. Let's say it's a photo of my cat, Cindy.jpg. And now I want to store this. And I take it, I break the file down into something like an object. And the object's given an object identifier so I can find it. And I now take that object or that file, which is now an object, Cindy.jpg, and I actually have some what's called metadata on or associated with this. And the metadata might be Cindy eating bonkers cat treats or Cindy chasing rabbits. And I can figure out what's actually in that data. Now that's very powerful because now I can search for things. I can create a big data environment, start pulling information from this data. Object storage is not new. Block storage is not new. We've been using it for 30 years in the data center, but on the cloud, they call it Blob. So what we have to understand is when our data is broken down into objects, they're going to be put in this repository. It's kind of be like a big giant environment where everything is just thrown in there. Now we'll be able to access the information by being able to know what we're looking for and looking at the object identifier. So if you actually look at object storage itself, what happens is we take this stuff, we shove it into this big giant storage environment, and we have information about it. Object ID, here's how to find it, and here's the information about it. Does that sound a lot like a database to you? Being able to find information in a database? So object storage is database-like. Everything is thrown into this big giant clump of storage hard drives, but you can find it based upon the link or the pointer to that object, which is pretty cool and it's pretty exciting, at least the way I look at it. By doing it this way, for example, we find ourselves in a position where we can put anything we want, we can find it anytime we want. Now, one of the things you have to remember is object storage is what's called write once, read many times. What does that mean? It means you can't read, write, and go back and forth to it. So your computer can't use object storage normally, like traditional storage, without some form of a storage gateway to do it for you. So our virtual hard drives on our virtual machines and our containers are going to be block storage for the most part for this reason. Hope that kind of makes sense. So if people ask what's used instead of fiber channel, everything is converged over the IP network now. So we basically tunnel fiber channel or tunnel SCSI over the IP network. So it's all done over the Internet Protocol network, the same ones that your network engineers built. We no longer need these backup fiber channel networks. So object storage is going to be there. So one thing we have to remember is every time we modify a file in traditional object storage, it creates a new version. So if I were a photo editor and I was trying to use object storage as my thing, and I did something around a person's eyes, that's going to be a new version. Did something to their hair, that's going to be a new version. Removed a wrinkle over here, that's going to be a new version. You're getting the point. So object storage is write once, read many times. We can't use it as a hard drive. Here's the main reason why. Every system has what's called virtual memory out there. And what's virtual memory? So the system I'm working on, it's got DRAM in it, right? That's my basic PC. It's got 256 gigs of DRAM. It's enough for me to do my job. Well, what happens if I was going to run a big data set and my PC now needed 2 terabytes of DRAM, but I didn't have 2 terabytes of DRAM? What happens is your computer can actually use your hard drive to pretend that it's memory. And that's typically called the page file in Windows, the swap file in Unix. And typically speaking, your page file or your swap file is 1.5 times larger than your DRAM. So if my PC has 256 gigs of DRAM in it, my swap file will be 1.5 times that, which is 384 gigs of DRAM if I did 84 of page file. Now that page file, every time I read or write to, it's going to change a new version, which could change 1,000 times in a second. So if I tried to use my PC with object storage for my swap file, I'd have a 384 megabyte file that might change 1,000 times a minute. We don't want that. Object storage. We use it for big data because of the metadata, backup and archival purposes. I use object storage to show photos of Cindy the cat. By the way, maybe we'll do some Cindy the cat photos later. I got a real cat, cute Cindy that I adopted. I love her. She's my little kid. But you get the point. And then we'll get off of the cat topic. Now, that is going to be Blob. Now, the next thing is going to be file storage. File storage is traditional storage. It is attached to your computer. It uses normal file systems like NFS for Linux or NTFS for Windows. And if you look at your hard drive and you click your main drive, let's say you're on a Unix machine, and then you've got root, and underneath root, you've got home. And underneath home, you've got your documents, your downloads, what have you. That's hierarchical. You could be on a Windows machine. You could have your C:// you've got your users, then you've got your downloads, you got your documents, you got your music, you got your photos, all in different folders. That's that. But where on else do we need to use file storage? Well, we're typically using file storage, and actually I'm going to draw them out for you so you truly understand it. So block storage, as we talked about, is going to be your virtual hard drive, which means it's going to be for one system. Object storage is going to be for backup and archival purposes. File storage is when multiple systems need to use it. So you may have seen in the past, you've got a file server, which is just a server. And let's say it's got 2 different hard drives. Let's say it's got a D drive on it. I'm putting it for Windows for you folks that are used to Windows. And then we share the D drive over the network. We turn this into a share. That'll be a server message block share. And then we've got computer A, computer B, and computer C. And I'm going to share this in a second. So here we've got a server. Bear with me. It's hard to always remember. Here's our file server. Let's say it's got a C drive and a D drive. We share D. And now A, B, and C can access all the information on this file server all at the same time. So what if I wanted a network boot all my computers off of this file server? I can. Or if all these servers have to share the same information at the internet at the same time, I'm not putting data on server A, B, and C. I'm keeping it on this file server. I update it on the file server and everybody can use it. So file sharing is used for multiple systems to access the same thing. File sharing is access for multiple systems. Block storage is a virtual hard drive. So that's where your databases are going to be. That's where going to be the storage on your virtual machines and containers will be. And file storage, so block storage, virtual hard drive, object storage, backup and archival, and file storage that many people actually use it. So they're the three basic types of storage. Now, the next kind of storage, and we're going to get into the specifics, obviously, of the cloud provider storage. But if you don't know what it is, what good is knowing the specifics? We're next going to talk about disk storage. So in our systems, we need to use block level storage. And they're going to be virtual hard drives. So we'll talk about later when we get to Azure storage, the ultra disk storage, the premium SSD, the standard SSD, and the standard hard drives. They're going to be, and we'll talk about it more later, the types of storage that you can use for your virtual machines and your containers. Blob will use for large amounts of unstructured data. It could be text files, photos, videos, PDFs, Excel spreadsheets. It really doesn't matter. We might have log files that we want to store for analysis later. Audio, video, movies, like Netflix basically streams off of object storage, for example. Backup, disaster recovery, these kind of things. So now we're talking about blob or object storage. We realistically have basically three kinds of blobs that Microsoft classifies. And they're going to be block, which is DBFS only, which we'll talk about later, append, and page. So we will have with our block storage several resources, which are going to be the storage account, in your customer information. It'll be a container inside of your storage account, and you'll have a blob inside of that. So, because at some point they may ask you some of these more geeky, more technical, more minutia type questions, and you need to know it for the exam. So we're going to talk about it. Now, in real life, you have to check these things each time you design a system. Why? Because they change. But at the time we created this content, the types of blobs we're going to talk about we're going to give you some information. So block blobs are going to store text and binary data, and they can store upwards of 190 terabytes. Append blobs are going to be similar to block blobs, but they're going to be optimized for more append operations, meaning logging data from the virtual machines. You know, when you've got a virtual machine and it spews this information on a Linux machine, and for example, you get a whole bunch of warnings and things every couple of seconds. Those are your log files. This person logged in, this person did this thing couldn't upstand itself. That you can put in a append blob. And you also have the option of a page blob, which is going to be random files upwards of 8 terabytes. So kind of keep that in the back of your mind. More of a virtual drive. So when we deal with blob storage, we're going to have several account resources. We're going to have a storage account, which is going to be the web address that includes the unique identifier and name of the storage account. It's going to have a container in the storage account, as I mentioned, but that's going to be organizing your blob sets. And it creates like a file directory. And then we've got the blob container, our blog container, our append, or our page blob. So I kind of hope that makes sense. Maybe this will help make sense of that. Sally has our account. She's got an account with pictures in it, a container that has pictures, and a container that has movies. So if we're going to store our stuff in a blob, we kind of have to encrypt it, right? What happens if somebody breaks into the Azure data center and steals their hard drives? All your information is now compromised. Now, if it is encrypted, well, then and only then the value of it is nothing without the decryption key. So let's briefly talk about what is encryption. Encryption is where I take something and I use whatever the key is to encrypt it, and when it comes out, it's gibberish unless you have the key. So we can look at some early rudimentary forms of encryption. There's a language in the Caribbean called patois, where people speak it so that that other people didn't understand what they said. When I went to school in America, we had this thing called Pig Latin, where you swap the A in the front of letters and nobody could figure out what you're saying unless they knew Pig Latin. Problem was, is a lot of people knew patois and a lot of people knew Pig Latin. Not that many Greek people in the world. There's only 10 million of them. So if I ran this course entirely in Greek and said, Posi sa pernel, isa daxi, and then I said, Posi sa yasel, ehis kolo anamasemera, only a small percentage of the people would use it. But still, there's 10 million people that know the Greek language, so that's not going to be the best encryption key. But if I could encrypt it where nobody else could understand it unless they had the decryption key, it would be much more secure. So that's encryption. Now, by default, when you use blob storage, it's going to be encrypted with AES 256-bit encryption, which is pretty darn strong. So it's going to give you really good encryption. And if you copy your data from primary regions to other regions, guess what? It's all going to be encrypted. So without the decryption key, you've got nothing. So we can encrypt the data before we send it, and that's called client-side encryption. Meaning, I encrypt it, and then I send it to storage. That's a possibility that we can use. There's other ways to do it. Now, when we talk about blob and storage, there's different types of storage tiers that we actually have. So let's talk about hot, cool, archive. What is it? So if you think about your data, there's a time where you're going to use a lot of data. So let's say in the 2 weeks that before this boot camp, my team was going back and forth. They were looking at things. They were fact-checking information to make sure things didn't change in the last couple of months. They were doing these things. That information was accessed every day. So maybe we would put that in hot access data. Why hot access? Because people are going to be working on it all the time. So hot access has the highest storage cost, but you don't pay anything to access it for the general rule. That's your hot access tier. Now, when this boot camp is finished, we're probably not going to talk about the Azure stuff we will inside of our classes, but when we train cloud architects, it goes about 1,000 times more architect related than you would find in a solution architect bootcamp or a certification, because the skills for the career are very different than the certification. So we might not use these slides for 2 months at a time. We may be focused on bigger and deeper architect things. So what if we could store our information on the cool access tier? Now, we store it on our OpenStack cloud. We run our own storage area networks, and it's substantially cheaper than using the cloud. But if I didn't know how to design these systems, I didn't have these systems, then I might use the cloud. I might keep the information for the 2 weeks or 4 weeks on the hot tier. I might put it on the cool tier so I can access it every once in a while. Now, if I create content and I need it today actively for a month or two, I can keep it where it's at. I can move it to the cool access tier to when I don't need it a lot. And when I'm not going to use it for at least 180 days or more, I could store it on the archive tier, which is going to be the cheapest price to store it, but I'm going to have to pay to access it, and it may not give it to me immediately. So when we deal with these tiers of storage in the cloud providers, that's what we're talking about. And how does that work? Well, they have different storage area networks where they just move your data to based upon what you're paying for it. So hot access tier is going to be for your data that is accessed all the time. It's going to be designed for heavier read and write loads, and it's going to be it's designed for faster processing. And at some point when you don't need it all the time, you're going to send it to the cool access tier. Now, the cool access tier is going to be used for infrequently accessed things, maybe some older data sets, short-term data backup, short-term disaster recovery, huge data sets where you're looking for a cost-effective way to put them somewhere, less availability, maybe a little you pay to receive it, extra latency, but it's still going to be there when you need it. And then there's that archive tier, which realistically speaking is for information that's rarely accessed, stored in more above 180 days. So let's talk about lifecycle management. What is lifecycle management in storage? Basically, you create a rule, and the rule is based upon how often you have it. Keep it in one tier, move it to another tier, and move it to another tier. So let's kind of talk about how we would do it. Maybe we'll draw it out architecturally to think about it, because I want you guys to understand it. So let's say we're working with a data set that matters a whole lot. And you got a bunch of people working on it. This is your hot tier. So you're putting on your really important data on your hot tier. Now, let's say, for example, I was hosting a blog on the hot tier. Now, or a news article for a newspaper. Let's say there's some big news. Apple's got a new iPhone 16, and let's say it does a great job with AI on the phone. I post that on my website, and that's going to get maybe, 1 million hits a day or more for the next week. Now, by the time 30 days have passed, almost nobody is looking at it, but somebody might click the link. So we might create a policy that says after 30 days, move that article to the mid tier that we're actually talking about, which is the warm tier or the cool access tier. Now, maybe for the next 90 days, somebody looks at this. So let's say this is 30 days over here. I need a text box to do this. 30 days, we move it from the hot tier to the cool tier. And then maybe what we do after 90 days later is we put it on the archive tier over here. So let's say the archive tier. Hello. So, and this is what we're talking about life cycle of our data. And this is typically a life cycle policy. You can do this on any cloud provider you want. And that's how you move your information to the systems that, I don't know if I spelled that correct, to the systems that are going to be the most cost effective at the time. So let's talk a little bit about versioning in Blob. So versioning is going to be a form of data protection. And realistically speaking, so it's going to create multiple versions of it. So I do it all the time when I write a document. I've written lots of books, lots of documents. I'm an architect. We write like 30% of the time. So I open up my architecture document. I start with version 1.0. I save it at the end of the day as version 1.0. The next day I open my document. I save it as 1.01. Next day I save it as 1.02. And that way, if my document got corrupt, if my cat Cindy walked on my keyboard and deleted a few pages, it happens. You'd be surprised. I don't lose anything because I go back to the old version. Well, generally speaking, object storage by default creates new version, but the cloud providers turn that feature off automatically so you don't pay for too much. But you can do versioning by enabling it back, the default behavior of object storage, and that way you can get access to certain things. So it's going to look like this. You're going to have multiple versions, and you can easily go back to the old version because you still have it versus the latest version. So let's talk about soft delete for blobs. And what is it? So soft delete for blobs is part of a comprehensive data protection strategy for the data that's in the system for a period of time. And while it's in this time frame, if you delete something or soft delete it, you can restore it. Any of you have a PC or a Mac and you delete something and it kind of sits in either that recycle bin or the trash for a period of time and you can bring it back? That's really what we're talking about. So none of this cloud technology is new. It's all 20, 30-year-old technology with new names. So it's all going to come from previous things that were previously invented. Now, how long for soft delete? Well, that retention period is going to represent, the data availability after you delete it. And the retention period begins with once the object is deleted or overwritten. Now, you can set the retention period because it can be between 1 day and 365 days. But after you specify that period, when it's gone, it all goes away and it's lost forever, which makes sense because if you're going to pay for every piece of data that you have, you're not going to want to store everything forever. You're not going to want to store different things. So it gives you the ability to get stuff that you threw away because you don't use anymore. And businesses might actually get rid of certain forms of old data because if you have too much data floating in the system that's easily accessible, well, hackers can get access to your data too. So there'll be lots of environments where we're going to have lifecycle policies, for example. Now, we also have soft delete for containers. And that's basically similar to what we're talking about, but it's going to be a protection strategy that protects the container. So as you recall, we went back to, let me go back to this document and make sure I remember where I'm actually at. Bear with me a second. So let me go back to showing you what I mean to make sure. You've got the account, you've got the container, and then you've got the blob. So Sally's got her account, he's got a container, pictures, and blob. The soft delete for blob is you delete image.0.0.1.jpg and you can still restore it like the recycle bin. The soft delete for containers is basically delete this whole pictures folder and you can bring it back. So I didn't share my screen for that. Apologies. So here's what we're talking about. We got the account Sally. And Sally has two containers, one for pictures and one for movies. The soft delete for blob, like we were previously talking about, is realistically speaking for one photo at a time. The soft delete for the container is for the photos. So I kind of hope that makes sense. So in this particular situation, you delete the container and the things underneath it. So I hope that kind of makes sense. We deleted blob, we restored blob. Now, how do we organize our data in these blobs? Well, if you'll recall, maybe I can show you this for a second. There, come with this for just a second. Look who's helping me do my my presentation. Her name is Cindy, and I know she doesn't like to be helped. Let's give a hashtag Cindy for anybody that likes cats. All right, let's go back to organizing data inside the blobs, all cats aside. So remember when I said blobs itself and object storage, we just shove stuff in there and we have a pointer to it. So we have to find a way to make it seem easy to understand. Now, the good news is with object storage, it kind of creates like a URL, which enables us to share information so easily. So we can create any kind of name we want, upwards of 1,024 characters long, which I always thought was kind of cool. We can create these limiters like forward slashes and backslashes to make it look hierarchical, just like file storage. But we have to remember, it's just stuff that's dumped into an environment with a pointer. Any of this hierarchy that we create or little delimiters like folders back and forth, forward slashes and backslashes, this slash if you're used to Linux and this slash if you're used to Windows and this slash if you're used to Linux or URLs, that's really what we're talking about. So I might actually create a version of something, like I'll pop it in the chat box. Like, what if I wanted to create an environment that looks like this? I'm going to pop it in the chat box right now, where I've got this http://gocloudcareers.blob.core.windows.net. It's a synthetic one we made to just prove the point. But looking at that, illustration. So I kind of hope that makes sense. We can create our files and make it look like this, specifically to assist us, the user. It's not going to be the reality of the way it's actually stored. So how else could we tune blobs? So we can do something called the shared access signature. And that's going to restrict access rights to storage resources. So we can be at the account level, the service level, or user delegation. We'll get through much more details as we go through this program. We can set some scalability targets, meaning the kind of performance we need, and we can tune that a little bit. We can partition our blob into multiple small blobs, because if each blob has a certain speed limitation and we partition it into 4 blobs, then we might have 4 times the speed. How else do we tune blob performance? Well, we have to make sure the network has the performance it needs. If the network's not weak enough and we need more network bandwidth, we're going to run into performance. We can also cache information that's valuable to us so that it's frequently accessed. It doesn't have to go to the blob storage in the first place. And for people that are using that .network framework, they can do some .net configurations as well. So now let's talk a little, Chris, maybe it's time to take a quick break and answer some questions on Blob before I get into encryption. Got some questions, bring them. We'll do what we can. From a security and compliance perspective, what would be the best practice to manage the life cycle of a security breach log or snapshot object storage for compliance? Francis, you're actually now asking an architectural type question. So there is no best practice. And people get in trouble with architecture when they look for the best practice. And I'll tell you why there is no best practice. Companies A's business needs are X. Companies Y's business and security needs are different. So if we try to apply the best practice of company X to company Y, we just hurt company Y. It's what happens when people try to look at somebody else's architecture without learning how to be architects and try to draw conclusions. So what does a military base need to understand? What does a bank need? What does a retailer need? So they're all going to be different. What are the security requirements? What is the brand failure? So anytime we're getting from a security and compliance perspective, Francis, we need to take it up a higher level. We first need to understand the organization that we have. We need to understand that organization's assets. We need to quantify the risk they have. What's the risk of a breach? What is their threat environment like? What they have. Then we also need to understand the quantity of the risk if something would be exposed, say in a security breach, both quantitatively, where we'd say look at the value of the asset, and then we would look at a percentage of loss expectations, for example, of what it would have be. And then we would look at the statistical likelihood of that breach occurring. And then from there, we can create a business case and we can determine what our security policy is. But if we fail to understand both the quantitative and qualitative factors, we don't know what we're protecting. A company that's got $1 billion new drug needs different access than someone that's got photos of my cat Cindy. So if we start looking for best practices, we're going to run into trouble. Now, what we can do as good architects, as good security consultants, as good security architecture is we can actually look at various industries and we can compare certain banks to other banks that are in similar and then change things as we go along. But the reason an architecture takes a team of 15 to 50 people, 6 to 12 months to design that architecture, the reason architects are not allowed to touch their client's technology, we're not allowed to code, we're not allowed to configure, is it's going to take us 3 to 6 months to get that information we need for just that one customer, long before we can think about it. So I hope that makes sense. We have to understand what we're needing, how long they need that data, how frequently they use that data, the risk of their data. It's so much more than just giving you a number straight off the hat. For tomorrow's session, should we use the same link? No, there will be a new link for every single day. My team will pop a link in the chat box. They just did. YouTube creates a different link for every video, and they'll probably store it on object storage as well. All right. Well, not a lot of questions on storage. I like it. Will tomorrow's session be at the same time? Yes, absolutely. But I really want you to come to Thursday's webinar. We're going to talk about how to become a cloud architect. And I'm also going to make sure we host very, very shortly a whole session, either on Zoom or on YouTube, of various career questions, because not everybody wants to be an architect. I mean, I think it's the greatest career. I wouldn't do anything else or recommend anything else because I love it so much. But we all have different goals. And I want to make sure you know what you need to be a cloud engineer versus say, an architect, because they're a completely different set of skills. And I want to make sure you guys get what you need. But on Thursday, we're going to have an architect webinar. So let's talk a little bit about Azure encryption models. So what is encryption? It's a technical safeguard to protect your data as it moves from point A to point B. We can encrypt it on the client side, meaning I want to send data to Alonzo, and I encrypt it before I set it in storage. Alonzo has the decryption key, and he pulls it down, and he gets it. Works great. If I encrypt it before I send it, that's called client-side encryption. It's already encrypted before it gets there. Now, the next type of encryption is called server-side encryption. And in this case, we're going to have three options. We're going to have the service managed keys, which means somebody else is going to manage our keys for it. Guess what? That's nice, low cost, and convenient. But if Azure manages my keys and Azure stores my keys and Azure gets hacked, well, we got a problem. Now, it's going to be pretty hard to get to Azure's keys, but understand, cloud providers get hacked all the time. They have networking events all the time, and there's challenges. So the next thing is the customer managed keys, where the customer controls all keys. Well, we control the keys, we bring them to Azure, and then Azure stores them. So first, the service managed keys, everything is done for us. The next thing we actually did was the customer managed keys, where we bring the Azure our keys, but they store them. Now, the next, which is typically what you do if you have extreme security needs, is you manage your keys in your own on-premise repository, and it's not stored in Azure. And that way, if anything happens to Azure, nobody can access your keys. So realistically speaking, customer managed keys means you need to get into a good key management solution. And it's not impossible, but it requires some degree of sophistication and maintenance. So you're going to use that for highly secure environments. Now, here's another way you can just encrypt things. Just encrypt the disk. You know, when you get a Mac and you turn on, or a Linux machine, you can encrypt your whole hard drive. Guess what? If it's stored on the hard drive, it's encrypted. So Windows has this concept of a bit locker. Linux does its own sort of encryption strategies. You can encrypt your virtual machines using a key encryption key, and you can back up that and restore it with Azure Backup Service. You could do storage service encryption, which is the data that would say on your blob be stored while it's there. So if we've got a database, specifically some databases like Microsoft SQL, for example, or Oracle, they typically do what's called transparent data encryption. And that means it's going to be encrypted and decrypted by the server as you pull the information. It's decrypted when it's sent to you. It's encrypted when you send it back to them. So you'll get to see it, and it's done on the server without you having to do it. So now we're going to talk about that key storage. So we're going to talk a little bit about so we're going to have the concept of the key vault and the key vault managed hardware security modules. So when we talk about these things, we'll talk about how to maintain the integrity of the encryption key. But the key vault's going to manage your secrets, your keys, and your certificates. Certificates like the SSL TLA based certificates, managing your keys and managing secrets. A secret would be like a database string or a password. So with Azure Encryption Key Management, what is it? It's basically is the administration of all the tasks that are associated with protecting, storing, backing up, and organizing your encryption keys. You can use your own encryption key to protect the data in your storage account. The customer data is the key customer managed key is going to be used to protect and control access to the key that's going to encrypt your customer data. And customer managed keys are going to give flexibility to manage the access controls. With the Azure Key Vault, what is it? Well, it's going to be a cloud service for securing your secrets. So your API keys, your certificates, your tokens, your passwords, any kind of thing that you need to secure. It's going to be simple and easy to control the encryption keys that are used. That's going to be your Azure Key Vault. Your Azure Key Vault, you can also use for your certificates, your TLS, SSL certificates, the kind that you use to go on a web server for HTTPS to prove that that web server is who it claims to be. And with Azure Key Vault, we actually have two service tiers. We've got the standard, which is going to encrypt the information with the software key. And then we have the premium tier, which is going to be a hardware security module to protect your keys. So it kind of looks like this. You're going to have your user who's going to access Azure via PowerShell, the portal, or say an API. They're going to have a storage account encryption key called the AEK. And we're going to be able to store information in the Azure Key Vault. And that information could be passed on to, say, Active Directory, which, of course, the name changed to Entrada AD. But realistically speaking, that's to determine who you are, what you're allowed to do, and keep track of it. In fact, when we talk about identity and access management, what is it really? It is, let's say, go back to me and Alonzo having that conversation. It is identification that Alonzo is, in fact, Alonzo Coleman, not somebody else. Then it's determining what Alonzo's allowed to do. Alonzo could do this, this, and this, but not this. And then it's keeping track of what Alonzo's done. So we used to call it, before we came up with the silly term identity and access management, we called it authentication. Who are you? Authorization. What are you allowed to do? And accounting. What have you done? So we're now going to talk about a uniform resource identifier. And that's just going to be a character sequence that's going to identify a logical or physical resource that may be connected to the internet. So it's going to distinguish one resource from another. But it's not a uniform resource locator, which is going to be, say, for a website. Let's talk a little more about the Azure Shared Access Signature. What's it for? It's going to grant limited access rights to storage resources through that URI, or that uniform resource identifier. Users will have permissions, limited permissions over a period of time, and they can access certain things based upon the shared access signature token they actually possess, which is going to be like IAM rights. It's going to be at the account level. At the account level, we'll be able to delegate access to resources in one of the various storage services. We'll be able to delegate access as to who can read, who can write the information, who can delete the information, that have you, whether it's in a blob container, table, file share, or what have you. And then we're going to have the service level where we'll be able to delegate access to one of the, maybe to blob or queue storage, file storage, or a table, because we're going to want certain people to access it. And then we have this concept of the shared access signature, which I keep talking about. Basically, it's secured in Active Directory. It's permissions for who can access what. So you might look at it like this. We've got a user that wants to get something. They authenticate. They get their shared access signature, which is a token, and that enables them to access various forms of information. So on the virtual machines, I want to make sure we talk about the two kinds of storage you have. In your servers, you're typically going to have very, very, very fast storage. Typically, you'll have a RAID card, and you'll typically have like 8 times 8 terabyte, not NVMe drives or really fast drives, and they sit on that environment in a RAID environment, typically RAID 5. Which means if we have 8 terabyte drives, we're going to be able to use 7 of those drives. One of those drives is going to be used for backup information. If we've got 7 drives and each drive is 7,000 megabit per second, we're going to have about 35,000 megabit per second of storage. And realistically speaking, several million input and output operations per second. That's the storage in your server. The problem is the storage in the cloud, and at least in the cloud virtual machines, is that it's ephemeral. So if you delete the server, you lose all the storage. It's not like a server that's got a data drive, and it's different from the primary boot drive. So there's that. So ephemeral storage is going to be the stateless storage that comes on the server that comes with the service. It's going to be really fast, but it's going to go away if you delete it. So we don't want that. But really fast. Keep that in the back of your mind. It's great for non-persistent workloads because nothing's going to be stored when you delete it. You can reset it quickly or re-image your virtual machines to the boot disk. It comes with your server, free of cards, but it's ephemeral, meaning it's going to go away. Which is going to be the exact different opposite as if you've got your virtual machine, you've got a local drive in the virtual machine, and then you're going to be storing your OS and your data on block storage, like we have here. So we're going to talk briefly. Let's see how much time I have on managed storage. We're going to talk about managed storage and potentially RAID, and then we'll take some questions, and then we'll finish for the day. But let's talk a little bit about managed storage. So what is managed storage in Azure? Well, managed storage is block storage. I don't know who makes up these crazy names. Block level storage. And block storage is going to be designed for your virtual machines. They're going to say it's designed for mission critical workloads. It's your only choice for virtual machine storage. So you might as well just get used to it. It's persistent. It scales. Remember, we walked through block storage and we said all you got to do is add capacity of stuff anywhere in the environment. So it's going to scale well. And you can create upwards of 5,000 virtual machine disk types inside of a subscription per region. And these are going to be in redundant environments, so they're relatively stable storage. Now, the way it's going to look is as follows. You're going to have your virtual machine. It's going to have these virtual hard drives. But they're really going to be somewhere else on that Azure network, that storage area network. It used to be via fiber channel. Now it's over IP connectivity, Internet Protocol connectivity. And what we can do is we've got our block storage volume, which is what these hard drives are. But how do we back them up? Well, if any of you have ever been familiar with, imaging systems, where you can take an entire hard drive and you can create a single image file. And that image file you could use to bring up a new virtual machine. That's what we're talking about here with Azure Managed Disk. What's going to happen is you're going to get a snapshot of it. A full snapshot is a full image of your hard drive. About 25 years ago, we used to use the software from Symantec. It was called Ghost. And basically, you could take a whole server, copy it to a single image. That's what we're really talking about here. We can create an entire read-only copy of the virtual hard drive. And we can use it as a point-in-time backup. We can come back to it. So we can create full snapshots of our systems. But that's going to occur if we use premium drives, but as well. But you can also store it on any kind of hard drive you want. We can also do what's called an incremental snapshot, which is a little different. So a full backup is I back up the entire server. And if I did a full backup Monday through Friday, on Monday, Tuesday, Wednesday, Thursday, Friday, I got a full backup on my server. That's a full backup. Now we're going to talk about an incremental snapshot, which is the same thing as an incremental backup. If those of you are familiar with backups, of course, it's going to be an image versus files. So an incremental backup is we create a full backup, and then after that, we only back up the changes. So if today I backed up my whole hard drive, and tomorrow I create a photo of Cindy, my cat, a video of Cindy, my cat, and a PowerPoint, instead of backing up all my systems, I back up the photo, the video, and the PowerPoint that day. That's an incremental backup. So how do you restore an incremental backup? Well, you take every single incremental backup plus the full back, and it gets restored. That's an incremental snapshot. Same way incremental backups work. So it looks like this. We basically have our disk. We get our first snapshot of the whole thing, and then incremental backup 1, 2, and 3. Much more efficient from a time perspective. Hopefully it works from a restoration perspective, because hopefully all your backups didn't lose their integrity. Because if you lose one of your backups along the way, you have a problem restoring it. So it's an option of a full snapshot or these incremental backups. Now, when we're talking about these disks, let's talk about them. I want you to understand that cloud storage, block storage is slow. Now, we're going to talk about it being fast because we've no choice, but you can buy a RAID card for your server that can give you 19 million IOPS. And so, I mean, we've got an input and output operations perspective with, incredible speed. Because this block storage is network storage, we've got the latency of the network. And yeah, Ghost was really great. But we have the latency of the network. Plus, we've got shared storage, so it's not going to be fast like the kind of storage we can get in the servers in our data center. But we're going to talk about ultra disks, premium SSD, standard SSD, and then the standard hard drive. So best performance we're going to get on with block storage is the ultra disk. That's going to be our fastest storage on Azure. We can it's designed for resource intensive input and output operational workloads. We can do up to 32 terabytes per region per subscription. We can increase it by calling Azure support, and we can have 300 IOPS per gig and up to 160,000 IOPS. Well, how fast is that? If you go to Best Buy and buy a Samsung 990 Pro, it's going to be a lot for $100. It's going to be a lot faster than this. So understand this is the fastest we can get. 160,000 IOPS is not a whole lot, but it's the fastest we get on the cloud. Tomorrow, we'll talk about how to kind of work around some of these poor storage performance things with regards to RAID and potentially other things that other providers work. But for right now, this is the fastest we get. Next down the list, we got a premium SSD. Azure would classify it as high performance, low latency. I would not. It's intended for input and output workloads. You can kind of think of it as a slower version of a traditional SSD that we used to use 10 years ago or 15 years ago, in that we can get upwards of 250 megabit per second, which is about half the speed of one of those 2.5-inch SSDs that we would normally get, a little less than half, and 75,000 IOPS. And not a lot, but we've got the Ultra Disk, which is a slower version of those NVMe drives that you stick in your system, much slower, but it's NVMe based. Premium SSD, which is going to give you a reasonable balance of price and performance. It's not fast, but it's not terrible. So kind of keep that. We have what's the ability to do some disk bursting. And what is bursting? Let's say your link is guaranteed this, but you have a little more for a second or two. And if the network has capacity, it'll give it to you. We've got that on these premium SSDs. And then standard SSDs you can think of as very slow speed. So I like to think magnetic storage, those old, big giant hard drives that are slow, that are spinning around going every time they move. It's great for servers that are not latency sensitive because it's really cheap, but it's real slow. It's got a lot of latency. So Ultra Disk, fastest we're going to get, not fast, but relatively fast. Premium SSD, not fast at all, less than a traditional old school SSD before we had these fast NVMe drives. And standard SSD is going to be much slower. And then it's a little faster than these magnetic disks that I was going to get crunch, 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 but it still is fairly slow, but not much. And then we've got the magnetic drives, which is going to be the lowest cost we possibly have. Latency tolerant workloads, potentially good enough for a development or testing scenario. Maybe not. Maybe you're going to need to use standard SSD for a dev test environment. So I am going to stop there and answer questions that we have. And I can take a few more questions or go a little longer. I can go to, say, 310 or 315 if questions pop up, Chris. I'm sorry, 510 or 515. Explain the life cycle tier of blob storage. So absolutely. So I actually drew it out, Mohammed. So let me go back to where I drew it out and come back and explain this. Mohammed, it's always good to see you. Hopefully you're having a nice day there in Somalia today. I like it when I get to know the people that are here. So in this particular case, and if you heard that, my cat wants tuna, so I'll get it to her in a few minutes. Let's say, Mohammed, in this particular environment, I have something that's very important that I'm going to access every single day for a period of 30 days. I'm going to put it in the hot access tier, which is going to give me, it's going to cost more to store it, but I can actually, but I can get it anytime I want it. And let's say after a period of 30 days, I'm not going to access that data very much at all. And I can save a good deal of money by putting it on this cool tier and keeping it there where I can get it immediately. I pay a lot less to store it, but I pay a retrieval fee every time I want to see it. And then let's say after 90 days of me only using it a little bit, now I'm going to store it for long-term archival purposes. But in this case, I may not be able to get it immediately, and I'm going to sacrifice paying a lot less to store it for the privilege of accessing the information when I need it. Hope that makes sense, Mohammed. Chris, me may go on to the next one if there is one. Wow. Well, I'll give you a minute to see if anything pops in from the first day. I know I had a lot of fun for the first day. While we're waiting to see if anybody else has any quick questions, if you had a good time, maybe give the video a like, maybe subscribe to the channel and hit the bell so you get notified of new videos and new things that we have. We produce a lot of videos around here. We interview a lot of other experts. For example, we may issue some authorities in networking, cloud computing, security, AI, lots of conversations with expert architects I've worked with for the last few decades. I want to make sure that we popped in the link for tomorrow's training. Chris just popped it into the chat box. I want to make sure you guys are all here. I also want to make sure that if you're going to be in a hands-on role, like a cloud engineer or a cloud admin or a DevOps engineer, you need to get hands-on. So we've got a large number of labs for you to actually do. Kind of keep this in the back of your mind. So I want you to do them. And if you want to be an architect and you want to get hands-on, go ahead and do it too. We're not hands-on in our jobs, but if you think building it is going to help you better understand it, I'm great with that. Fantastic interview. You currently hold the AZ900 and excited to grow your cloud knowledge. I'm thrilled you're here too, Jared. Join us here. Join us on some of the free webinars. Come and get as much as you can. Nate, I love that. Hey, Mike, are any companies moving back to storage for on-prem for anything given some high cloud costs? Robert, there's been a lot of cloud repatriation, a tremendous amount. Generally speaking, doing anything on the cloud costs about 250% more than it costs to do it in the data center. Having said that, the cloud is more agile. So what you saw was people went to the cloud because they got a bunch of certified people that knew nothing about cloud computing, and they believed that it was going to be better, faster, and cheaper. They found out that it was slower. They found out that it cost more. So many organizations did that cloud repatriation movement. You may have heard me and David Lithicum go back to the data center. And then more people realized what AI could do. And now they're all going back to the public cloud. Of course, the more sophisticated organizations are using this hybrid multi-cloud look. So lots of companies are moving the storage back. And here's an example. I have two high availability 96 terabyte RAID arrays that I use in my business. They were each $5,000, which is no big deal. I put one in my home in Philadelphia. I put another one in my home in Florida. I've got multiple internet connections at both locations, and I keep these things synchronized. It cost me $10,000 for the two of them, and to buy it on the cloud, it was about $3,800 a month. So I can spend $10,000 one time for the course of 4 years, or I can pay over the course of 4 years about $150,000 to put it in the cloud providers. For my business needs, I actually run my own RAID arrays in two different environments, both of my homes. But that's me and my needs. So lots of companies are moving to the cloud. Lots of companies are coming back from the cloud. Lots more companies will go to the cloud. Going to the right reasons, putting your systems that run 24 hours a day, 7 days a week at high utilization runs best in the data center. Hence the private cloud, a Nutanix cloud, an OpenStack cloud, a VMware cloud. By comparison, things that require scalability, agility, or move periodically are much typically cheaper on the public cloud. So that's why you see hybrid multi-cloud in 98% of consumers. Nobody, for the most part, is going to do a single cloud. Good question there, Robert. Yeah. Can I please share my slides for you? I have no slides to share. If you actually looked at what I actually did on 90% of the slides, unless it's something that I'm not intimately familiar with, it's a word that says discuss block storage, discuss block storage problems, discuss block storage trends. So I don't read off of slides. I'm an architect. And there's this concept of what's called death by PowerPoint. And when you train to be an architect or an executive, you don't read off of your slides. In fact, in an architect role, if you did it, you'd typically be sent home because someone said, I don't read off of slides. I don't have slides to share because if you notice, I'm whiteboarding things in real time with you. I've had a couple of slides where I've had things written down and I've shared them with you, but I'm an architect. This stuff is in my mind. This stuff is in my heart, and I've done it for 25 years. So instead of focusing on slides, I focus on making sure people understand it. So I've got no slides to read, but you can watch this video anytime you want. All right. Well, I hope you've had a great day, everyone. I hope you've actually gotten some value and learned some things. Let you know that in the description of many in these videos, we've got things to help you in your career, documents on how to become a cloud architect, documents on how to become an AI architect. They're all free webinars that we do. There is a tremendous amount of free content that I'd love you to get access to. Look in the description of this video and go download some free things. So there's that. So let me just ask the question. I'm going to end after I go to the question of GD Gamer. So, and we'll talk more. You recently started learning GCP. Do you think you consider GCP or swap to Azure? There is no Azure, AWS, or GCP. It's all the same thing. All cloud computing is renting space in someone else's network in a data center. If you know one cloud, you know all clouds. And that's why, if you notice, in this first week, we're doing a whole lot of stuff that doesn't feel very Azure-like, even though it's under the context of Azure, where I'm mapping out these point of presences and how they work. You may have noticed that I talked about edge computing and drew these things out, and I talked in terms of block storage, object storage, and file storage. Because if I've got a virtual machine and AWS calls it EC2 and Microsoft calls it an Azure virtual machine and Oracle calls it a virtual machine and Google calls it a compute engine instance, it's the same thing. If I talk about object storage and I teach you object storage, it doesn't matter if it's Dell EMC's object storage, AWS S3, Google Cloud Storage, or Azure. So it really doesn't matter. It's the same stuff. I want you, so GD Gamer, I would look at it this as, do you get certified to learn how to drive a Toyota and only know how a Toyota works and only know the Toyota names for, say, the steering wheel? No, you learn how to drive a car. You learn the cloud. And you know all the clouds. Sure, we teach AWS around here, Azure, Google Clouds. I teach them all. But if you really know one cloud, you will always know more. So instead of worrying about memorizing the name of Azure services or Google services, learn the cloud. We'll talk much more about that if you join us in the How to Get Your First Cloud Architect webinar. You know BGP. You know whether it's on a Cisco router, a Juniper router, AWS, Azure, Google, Alibaba, Dell's Cloud, HP Cloud. It doesn't matter. Learn the underlying tech. Don't focus on the product. Learn the underlying technology, and you can work anywhere. And you want another big bonus for learning the tech? Every time the tech changes and the cloud provider comes up with a new name, you'll be able to say, oh, been there, done that. I worked with that 26 years ago. They called it something different. So I kind of hope that makes sense. Learn the cloud. Don't worry about any of these cloud providers and their proprietary names of things. Learn Google, learn AWS, learn Azure. Everybody's multi-cloud, but I hope that makes sense. So give it a hashtag like. I look forward to seeing you all tomorrow. Let's have some fun. Make sure you check out those free resources. Please give the like, subscribe, tell a friend to go watch what we did, and have a wonderful night. And I'll see you all tomorrow.